7th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 1, Relationships Between Quantities. Problem number 1 from 7th grade Unit 3, Lesson 7. Lynn and Tyler are drawing circles. Tyler's circle has twice the diameter of Lynn's circle. Tyler thinks his circle will have twice the area of Lynn's circle as well. Do you agree with Tyler? I don't agree, because the size of the radius is not proportional to the size of the area. Here's an example. These circles are not to scale, but let's use the larger circle on the left as Tyler's circle and Lynn's circle, the smaller circle, on the right. The diameter of Tyler's circle is 2 units. That's twice the diameter of Lynn's circle if the diameter of Lynn's circle is 1 unit. The formula for finding the area of a circle is pi times the radius squared. Since the radius is half the diameter, the radius of Tyler's circle would be 1 unit, so we can substitute the r with a 1. Now it reads pi times 1 squared. 1 squared, or 1 times 1, equals 1. We can use 3.14 for pi. 3.14 times 1 equals 3.14. The area of Tyler's circle is approximately 3.14 units squared. Lynn's circle has a diameter of 1 unit, so the radius for Lynn's circle is going to be half of that, or 0.5 units. Pi times 0.5 squared. 0.5 squared, or 0.5 times 0.5 equals 0.25. So 3.14 times 0.25 equals approximately 0.785. The area of Lynn's circle is approximately 0.785 units squared. 3.14 is 4 times larger than 0.785. This tells me that the area for Tyler's circle is 4 times larger than the area of Lynn's circle. Not 2 times larger or twice the area of Lynn's circle like Tyler thinks. Problem number 2 from 7th grade Unit 5, Lesson 15. Jada and Priya are trying to solve the equation 2/3 plus x equals 4. Jada says, I think we should multiply each side by 3/2 because that's the reciprocal of 2/3. Priya says, I think we should add negative 2/3 to each side because that is the opposite of 2/3. A. Which person's strategy should they use? Why? I think they should use Priya's strategy. Adding the additive inverse of 2/3 or adding a negative 2/3 to both sides will get x by itself. Because 2/3 minus 2/3 cancels each other out and you have the x by itself. Now you're left with x equals 4 plus negative 2/3 or 4 minus 2/3, which is equal to 3 1/3. So we know that x is equal to 3 1/3. Again, I think Priya is correct because adding the additive inverse of 2/3 to both sides of the equation will help you solve for x. B. Write an equation that can be solved using the other person's strategy. They want us to use Jada's strategy. I'm going to leave the equation the way it is. 2/3 plus x equals 4. Let's test it out by using Jada's strategy and see if it actually works. Jada wants us to multiply each side by 3/2. That means she wants to multiply the left side by 3/2 and the right side by 3/2. 3/2 times 2/3 plus 3/2 times x. That equals 6/6 plus 3/2 times x. And 6/6, or 6 divided by 6, equals 1. So on the left side, we have 1 plus 3/2 times x. On the right side, we have 4 times 3/2, or 4/1 times 3/2, which equals 12/2, and 12/2 is the same as 12 divided by 2. 12 divided by 2 is 6. So what we have now is 1 plus 3/2 times x equals 6. We still haven't solved for x. We need to subtract 1 from both sides. That leaves us with 3/2 x equals 5. 3/2 x is the same as 1/2 x. We want to know what the value for 1x is. So we have to multiply both sides by the reciprocal of 3/2, which is 2/3. 2/3 times 3/2 x equals 1x, or x. So now we have x equals 5 times 2/3. Or 5 over 1 times 2/3. 5 times 2 is 10, and 1 times 3 is 3. So x equals 10 over 3. 10 over 3 is the same as 10 divided by 3. 3 goes into 10 3 times with 1/3 left over. So it just so happens that Jada was also correct, but it took much longer to find the value for x. Remember, the equation that I wrote to answer B was the original equation, 2/3 plus x equals 4. Problem number 3 from 7th grade, Unit 5, Lesson 13. What are the missing operations? A. What operation can we substitute with the question mark to make this true? A division sign, because 48 divided by -8 equals -6. B. What operation can we substitute with this question mark to make this true? Another division sign, because -40 divided by +8 equals -5. C. What operation can we substitute with this question mark to make this true? A subtraction sign, because 12 minus a -2 is the same as 12 and the opposite of -2, which is 12 plus 2, or 14. D. What operation can you substitute with this question mark to make this equation true? An addition sign, because 18 plus a -12 equals 6. That's the same as 18 and take away 12 equals 6. E. What operation can we substitute with this question mark to make this equation true? An addition sign, because 18 plus -20 equals -2. That's the same as 18 and take away 20 equals -2. F. What operation sign can we substitute with this question mark to make this equation true? A multiplication sign, because 22 times a -0.5 equals -11. Another way to think of this is a positive times a negative equals a negative, and 0.5 is equal to half. This is like half of 22. Half of 22 is 11. And remember, the answer is a negative, -11. Problem number 4 from 7th grade, Unit 5, Lesson 14. In football, the team that has the ball has 4 chances to gain at least 10 yards. If they don't gain at least 10 yards, the other team gets the ball. Positive numbers represent a gain, and negative numbers represent a loss. Select all of the sequences of 4 plays that result in the team getting to keep the ball. A. They gained 8 yards, they lost 3 yards, gained 4 more yards, and gained 21 yards. That's a total gain of 30 yards, so they get to keep the ball. B. They gained 30 yards, then they lost 7 yards, they lost another 8 yards, then they lost another 12 yards. That's a total gain of 3 yards. Since they didn't have a total gain of at least 10 yards, they will not get to keep the ball. C. They gained 2 yards, then they gained 16 yards, then they lost 5 yards, and then they lost 3 yards. That's a total gain of 10 yards. Since they gained at least 10 yards, they get to keep the ball. Problem number 5. A sandwich store charges $20 to have 3 turkey subs delivered and $26 to have 4 delivered. A. Is the relationship between number of turkey subs delivered and amount charged proportional? Explain how you know. Since $20 divided by 3 subs equals $6.66 per sub, and $26 divided by 4 subs equals $6.50 per sub, I would say that this is not proportional. B. How much does the store charge for 1 additional turkey sub? 3 turkey subs for $20 and 4 turkey subs for $26. The difference between $26 and $20 is $6. So for 1 additional sub, they're charging $6 more. C. Describe a rule for determining how much the store charges based on the number of turkey subs delivered. The rule can be $6 times the number of subs plus a $2 delivery fee. Let's test it out. 3 subs times $6 equals $18 plus a $2 delivery fee. That equals $20 to have 3 turkey subs delivered. 4 subs times $6 equals $24 plus a delivery fee of $2. That's a total of $26 to have 4 turkey subs delivered. Problem number 6. Which question cannot be answered by the solution to the equation 3x equals 27? 3x equals 27. 3x divided by 3 equals 1x, and 27 divided by 3 equals 9. So we're looking for a situation when x does not equal 9. A. Elena read 3 times as many pages as Noah. She read 27 pages. How many pages did Noah read? The amount of pages that Elena read equals 3 times the number of pages that Noah read. And Elena read 27 pages, so we can rewrite this as 27 equals 3 times n. 3n divided by 3 equals 1n, or n, and 27 divided by 3 equals 9. This means that Noah read 9 pages. Remember, we're looking for a variable that does not equal 9, so don't select A. B. Lynn has 27 stickers. She gives 3 stickers to each of her friends. With how many friends did Lynn share her stickers? 27 stickers divided by 3 stickers equals 9 friends. This means that Lynn gave 3 stickers to 9 different friends. Remember, we're looking for a variable that does not equal 9, so don't pick B. C. Diego paid $27 to have 3 pizzas delivered and $35 to have 4 pizzas delivered. What is the price of 1 pizza? 27 divided by 3 equals 9. Here, the average price of each pizza was $9, and 35 divided by 4 equals $8.75. For this delivery, the average price of each pizza was $8.75. This tells me that the price of the pizza, or the variable, cannot equal 9, since the price per pizza, or the variable price, varies with the number of pizzas ordered. So this is the answer that we've been looking for. Equation C cannot be answered by the solution to the equation 3x equals 27. Let's try the last situation. D. The coach splits a team of 27 students into 3 groups to practice skills. How many students are in each group? 27 students divided by 3 groups equals 9 students in each group. This situation can be answered by the solution to the equation 3x equals 27, so we cannot select D. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. 7th grade Illustrative Mathematics. Unit 6, Lesson 2, Practice Problems. Number 1. The table shows the number of apples and the total weight of the apples. Estimate the weight of 6 apples. Well, the weight of 2 apples is 511 grams, and 2 times 3 is 6. So 511 times 3 would give you the weight of 6 apples. 6 apples would weigh approximately 1,533 grams. Number 2. Select all the stories that the tape diagram can represent. A. There are 87 children and 39 adults at the show. The seating in the theater is split into 4 equal sections. That doesn't work. B. There are 87 first graders in aftercare. After 39 students are picked up, the teacher put the remaining students into 4 groups for an activity. That works. C. Lynn buys a pack of 87 pencils. She gives 39 to her teacher and shared the remaining pencils between herself and 3 friends. That would work. D. Andre buys 4 packs of paper clips with 39 paper clips in each. Then he gives 87 paper clips to his teacher. No, that doesn't work. E. $87 is spent on 4 tickets to the fair and a $39 dinner. That would work. Number 3. Andre wants to save $40 to buy a gift for his dad. Andre's neighbor will pay him weekly to mow the lawn, but Andre always gives a $2 donation to the food bank in weeks when he earns money. Andre calculates that it will take him 5 weeks to earn the money for his dad's gift. He draws a tape diagram to represent the situation. A. Explain how the parts of the tape diagram represent the story. X represents the amount Andre is paid each time he mows the lawn. -2 or -2 represents Andre's donation to the food bank. 40 represents the amount Andre will save to buy a gift. Each of the 5 sections represents a week. B. How much does Andre's neighbor pay him each week to mow the lawn? Since 5 times 8 equals 40, and 10 minus 2 equals 8, X must equal 10. Andre is paid $10 each week to mow the lawn. Number 4. Without evaluating each expression, determine which value is the greatest. Explain how you know. A. 7 and 5/6 minus 9 and 3/4 will equal a negative value. B. A negative plus a negative is going to equal a negative value. C. A negative value times a positive value is going to equal a negative value. D. A negative value divided by a negative value is going to equal a positive value. Out of all 4 of these expressions, the expression with the greatest value is D, because it's a positive value, and the other 3 expressions are all negative values. Number 5. Solve each equation. A. 8 and 5/10 times -3. Well, a positive times a negative is a negative. So 8 and 5/10 times 3 is 25 and 5/10. So A equals -25 and 5/10. B. -7 plus B equals -11. If you add 7 to both sides, you can get B alone. -7 plus 7 cancels each other out, and -11 plus 7 is -4. B equals -4. C. C minus a -3 equals 15. Well, minus a negative is the same thing as adding a positive. So C minus a -3 equals 15 really means C plus 3 equals 15. Now we need to subtract 3 from both sides to get the C by itself. 3 minus 3 is 0, so those cancel each other out, and 15 minus 3 is 12. C equals 12. D. D times a -4 equals 32. We need to divide both sides by -4 to get the D alone. D times a -4 divided by a -4 is D, and 32 divided by -4 is -8. D equals -8.
Seventh grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 3, Reasoning About Contexts with Tape Diagrams, Part 2. Problem number 1 from 7th grade Unit 5, Lesson 15. Solve each equation mentally. A. 2 times x equals 10. Since 10 divided by 2 equals 5, I know that 2 times 5 equals 10, so x equals 5. B. Negative 3 times x equals 21. Well, I know that a negative times a negative equals a positive, and I know that 21 divided by 3 equals 7. So in this case, x equals negative 7. C. 1/3 times x equals 6. So that looks like a positive times a positive equals a positive. And 6 divided by 1/3 equals 18. But I also know that 6 is 1/3 of 18. So x equals 18. D. Negative 1/2 x equals negative 7. I know that a negative times a positive equals a negative. So x is going to be a positive. And 7 divided by 1/2 equals 14. I also know that 7 is half of 14. X equals 14. Look at the equation one more time. We can think of it as half of 14 equals 7, so negative half of 14 equals negative 7. Problem number 2 from 7th grade, Unit 5, Lesson 3. Complete the magic squares so that the sum of each row, each column, and each diagonal in a grid are all equal. Look at the first grid on the left. They've given us the 0, the 7, and the 2. If we add those up, the total sum is 9. Each row, column, and diagonal have to have the sum of 9. Let's go to the middle column. 7 plus 3 is 10, minus 1 is 9. Now the bottom row. 4 minus 1 is 3, and 3 plus 6 is 9. So the sum of this bottom row is equal to 9. Let's go to the right-hand column. 6 plus 1 is 7, plus 2 is 9. So the right-hand side column has a sum of 9. Let's go to the empty box on the left. 5 plus 3 plus 1 is 9. And vertically, on the left side, we can go 0 plus 5 plus 4 is 9. Let's check some of the rows, columns, and diagonals. 5 plus 3 plus 1, that's 9. 4 plus 3 plus 2, that's 9. And 0 plus 3 plus 6, that's 9. Let's move over to the next grid. They've given us the 1, the 3, and the 5. That also totals 9. So in this grid, each row, column, and diagonal needs to total 9. On the right-hand vertical column, 6 minus 2, that's 4, and 4 plus 5 equals 9. Let's go to the column on the left. 1 plus 8 plus 0, that equals 9. Across the top, 1 plus 2 plus 6, that equals 9. Vertically, 2 plus 3 plus 4, that equals 9. Diagonally, 0 plus 3 plus 6, that equals 9. Across the bottom, 0 plus 4 plus 5, that equals 9. Let's move over to the next grid. They've given us 4 plus 2 plus 0, that equals 6. For this grid, every row, every column, and every diagonal needs to have the sum of 6. The left column, 3 plus 4 minus 1, that equals 6. Across the top, 3 minus 2 plus 5, that equals 6. The middle row, 4 plus 2 plus 0, that equals 6. Across the bottom, negative 1 plus 6 plus 1, that equals 6. Left-hand column, 3 plus 4 minus 1, that equals 6. Middle column, 6 plus 2 minus 2, that equals 6. Right-hand column, 1 plus 0 plus 5, that equals 6. This diagonal, 3 plus 2 plus 1, that equals 6. The other diagonal, 5 plus 2 minus 1, that equals 6. Problem number 3. Draw a tape diagram to match each equation. A. 5 times x plus 1 equals 20. Here I've drawn a tape diagram with x plus 1 drawn out 5 times, and altogether it equals 20. B. 5x plus 1 equals 20. So here you can see that I've drawn x 5 different times and then added 1. Together, that equals 20. Problem number 4. Select all the equations that match the tape diagram. A. 35 equals 8 plus x 6 different times. Yes, that matches the tape diagram perfectly. Within the total of 35, you have an 8 added to 6 different x's. B. 35 equals 8 plus 6 times x. Again, that's correct because you have a total of 35 and that equals 8 plus 6 times x. C. 6 plus 8x equals 35. That does not work because 6 plus 8x isn't the same as 8 plus 6x. D. 6x plus 8 equals 35. That's a perfect match because it's actually the same as 8 plus 6x equals 35 because the order doesn't matter. E. 6x plus 8x equals 35x. This is incorrect. First of all, the tape diagram doesn't equal 35x, it equals 35. And 8x is not the same as 8. F. 35 minus 8 equals 6x. This is a perfect match because if you subtract 8 from 35, what you'll have left over is 6x. The equations that match the tape diagram are A, B, D, and F. Problem number 5 from 7th grade Unit 4, Lesson 2. Each car is traveling at a constant speed. Find the number of miles each car travels in 1 hour at the given rate. A. This car travels 135 miles in 3 hours. So the given rate is 135 miles in 3 hours. Let's figure out what that is in a unit rate. We can divide 3 by 3 to get 1 and divide 135 by 3 to get 45. 3 times 45 equals 135 and 1 times 45 equals 45. This car travels 45 miles in 1 hour. The given rate for B is 22 miles in a half an hour. Multiply the half hour by 2 and it becomes 1 hour. Multiply 22 miles by 2 and it becomes 44 miles. The car for B is traveling 44 miles in 1 hour. C. The given rate is 7.5 miles in 1/4 of an hour. We can multiply 1/4 times 4 to make it 1 hour, and we have to multiply 7.5 times 4, which is 30. So car C is driving 30 miles in 1 hour. The given rate for car D is 100 over 30 miles in 2/3 of an hour. We can multiply 2/3 by its reciprocal, 3 over 2, to get 1, and multiply 100 over 3 by 3 over 2. We can cross cancel. 3 goes into 3 once, 2 goes into 2 once, and 2 goes into 100 50 times. So we're left with 50 over 1, which is equal to 50. So car D travels 50 miles in 1 hour. The given rate for E is 97 1/2 miles in 3/2 hour. 3/2 of an hour is the same as 1.5 hours. We need to find out how many miles in 1 hour. We can multiply by the reciprocal of 3/2, which is 2/3. That gives us 1 hour. We need to multiply 97 1/2 mile by 2/3. We need to change it from a mixed number to an improper fraction. 2 times 97 plus 1. That equals 195 over 2. Cross cancel. 2 goes into 2 once, 3 goes into 3 once, and 3 goes into 195 65 times. We end up with 65 over 1, which is 65. So the speed of the car for E is 65 miles in 1 hour. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 4, Reasoning about Equations and Tape Diagrams, Part 1. Problem number 1 from 7th grade Unit 3, Lesson 1. Draw a square with side length 7 centimeters. A. Predict the perimeter and the length of the diagonal of the square. I've drawn a square with side lengths 7 centimeters. The perimeter is all the lengths around the square, 7 plus 7 plus 7 plus 7, or 7 times 4, and that's 28.
The perimeter is going to be 28 centimeters. It's going to be a little bit trickier guessing the length of the diagonal line. We know it's going to be longer than 7 centimeters in length, but how much longer? Let's take the diagonal line and rotate it so it's parallel with the side length. Since the side lengths are 7 centimeters long, we can put a mark about halfway, which would represent half of 7. That's about 3.5 centimeters. I can use this mark as a guide to help me mark individual units. After marking 7 centimeters, I can continue marking centimeters till I go past the end of the line. I know this is not exactly a prediction, but I'm also not using a ruler. I'm just estimating it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9.5, and it's a little bit beyond 9.5. Maybe it's about 9.6 centimeters. My prediction for the perimeter is 28 centimeters, and we know that the diagonal line will be more than 7 centimeters. My prediction for the length of the diagonal line is about 9.6 centimeters. B. Measure the perimeter and the length of the diagonal of the square. Well, the perimeter is 7 times 4, or 28 centimeters, and the length of the diagonal line is 9.9 centimeters. C. Describe how close the predictions and measurements are. I was correct with the perimeter. My prediction for the length of the diagonal line was 3/10 too short. Problem number 2 from 7th grade Unit 5, Lesson 9. Find the products. Products mean multiply. A. This is a positive times a negative, so I know my answer is going to be a negative. I'm multiplying negative 0.09 by 100. That means I need to move the decimal 2 places to the right. So 100 times negative 9/100 equals negative 9. B. I'm multiplying a negative times a negative, so I know my answer is going to be a positive. 7 times 11 is 77, so 7 times 1.1 is going to be 10 times smaller than 77, or 7.7. C. This is a negative times a positive, so I know my answer is going to be a negative. 5 times 7 is 35, and 0.3 times 5 is 1.5, so 35 plus 1.5 is 36.5. So negative 7.3 times positive 5 equals negative 36 and 5/10. D. This is a negative times a negative, so I know my answer is going to be a positive. And 2/10 times 3/10 is 6/10. So negative 2/10 times negative 3/10 equals positive 6/10. Problem number 3. Here are 3 stories. A family buys 6 tickets to a show. They also pay a $3 parking fee. They spend $27 to see the show. Diego has 27 ounces of juice. He pours equal amounts for each of his 3 friends and has 6 ounces left over for himself. Jada works for 6 hours preparing for the art fair. She spends 3 hours on a sculpture and then paints 27 picture frames. Here are 3 equations. A. Decide which equation represents each story. What does x represent in each equation? 3x plus 6 equals 27 matches Diego's story, and x represents the equal amount of ounces given to each friend. 6x plus 3 equals 27 matches the family buying 6 tickets story, and x represents the price of each ticket. The plus 3 represents the parking fee that they paid. 27x plus 3 equals 6. That matches Jada's story. X represents the time Jada spent on each picture. And the plus 3 represents the 3 hours she spent on the sculpture. B. Find the solution to each equation. Explain or show your reasoning. 3x plus 6 equals 27. We need to solve for x. We can solve this in 2 steps. First, let's take away 6 from both sides.
Now we have 3x equals 21. Now to solve for x, we have to divide both sides by 3. That's the second step. 3x divided by 3 equals 1x, or x, and 21 divided by 3 equals 7. Let's move on to the next equation. 6x plus 3 equals 27. Let's take away 3 from each side. Now it reads 6x equals 24. To get the x by itself, we need to divide by 6 on both sides. 6x divided by 6 equals 1x, or x, and 24 divided by 6 equals 4, so x equals 4. Let's solve for x on the last equation. 27x plus 3 equals 6. We need to subtract 3 from both sides. 27x plus 3 minus 3 equals 27x, and 6 minus 3 equals 3. Now the equation reads 27x equals 3. To get the x by itself, we need to divide both sides by 27. 27x divided by 27 is 1x, or x, and 3 divided by 27 is 3 over 27, or 3/27. And that can be simplified. 3 divided by 3 equals 1, and 27 divided by 3 equals 9. So x equals 1/9. C. What does each solution tell you about its situation? Well, the first one tells me that Diego gave each friend 7 ounces of juice. The second one tells me that each show ticket costs $4. And the third one tells me that Jada spent 1/9 of an hour painting each frame. Problem number 4. Here is a diagram and its corresponding equation. Find the solution to the equation and explain your reasoning. 6x plus 11 equals 21. I know that 21 minus 11 equals 10, so 6x must have the value of 10. We can write that as the equation 6x equals 10. Solve for x by dividing both sides by 6. 6x divided by 6 equals 1x, or x, and 10 divided by 6 equals 1.6 repeating, or as a mixed number, x would equal 1 2/3. Problem number 5, from 7th grade Unit 5, Lesson 7. A. Plot these points on the coordinate plane. To plot these points, you always have to start at the origin. The origin is this location here where the x-axis, or the horizontal axis, intersects with the y-axis, the vertical axis. Point A, the coordinates are 3 and 2. That means that we're going to move to the right 3 places from the origin and move up 2 places. In other words, you start at the origin, move to the right along the x-axis 3 units, then you move vertically 2 units. That's where you can put your point and label it A. B. The coordinates for B are 7.5 and 2. That means that you start at the origin, move to the right 7.5 units, and then move vertically 2 units. This is the location where you can plot the point for B and label it B. C. The coordinates for C are 7.5 and negative 2.5. This means you're going to start at the origin, move to the right 7.5 units, then you're going to move down vertically 2.5 units. This is the location you would plot point C. D. The coordinates for point D are 3 and negative 2. This means you're going to start at the origin, move to the right along the x-axis 3 units, then down vertically 2 units. This is the location you would plot point D. B. What is the vertical difference between point D and point A? Here you can see the number of units between point D and point A. But remember, the question asks, what's the vertical difference between D and A? And difference means subtraction. The problem would be the y value for point D minus the y value for point A. That's because the y-axis is the vertical axis. Since the y value for point D is negative 2 and the y value for point A is 2, we can rewrite this as negative 2 minus 2 because we're finding the vertical difference, and difference means subtraction. Since negative 2 minus 2 equals negative 4, then we can say the vertical difference between point D and point A is negative 4. C. Write an expression that represents the vertical distance between point B and point C. The y value for point B is 2, and we're finding the vertical difference between point B and point C. So that means that this is going to be a subtraction problem. So the y value for B, which is 2, minus the y value for C, which is negative 2.5. So the expression would be 2 minus negative 2.5. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 5, Reasoning about Equations and Tape Diagrams, Part 2. Problem number 1 from 7th grade Unit 4, Lesson 2. Here are some prices customers paid for different items at a farmer's market. Find the cost for 1 pound of each item. A. $5 for 4 pounds of apples. 4 pounds of apples divided by 4 equals 1 pound of apples. $5 divided by 4 equals $1.25. So apples are $1.25 per pound. B. $3.50 for a half a pound of cheese. A half a pound times 2 equals 1 full pound, and $3.50 times 2 equals 7. So 1 pound of cheese costs $7. C. $8.25 for 1.5 pounds of coffee beans. 1.5 pounds divided by 1.5 equals 1 pound. 8.25 divided by 1.5 equals 5.5. So 1 pound of coffee cost $5.50, or $5.50 per pound. D. $6.75 for 3/4 of a pound of fudge. 3/4 of a pound divided by 3/4 equals 1 pound. $6.75 divided by 3/4 equals 9. So 1 pound of fudge costs $9. E. $5.50 for 6 1/4 pounds of pumpkin. 6 1/4 pounds divided by 6 1/4 equals 1 pound. $5.50 divided by 6 1/4 equals 88 cents. This means that pumpkin sells for 88 cents per pound. Problem number 2 from 7th grade Unit 5, Lesson 9. Find the products. A. We have a positive times a negative, which equals a negative. 2 times 4 is 8, and 3 times 5 is 15. B. We have a negative times a positive, which equals a negative. We can cross cancel, and this leaves us with negative 1 times 1 over 1 times 1. And negative 1 over 1 is the same as negative 1 divided by 1, which is equal to negative 1. C. Negative 2 over 39 times 39. This is a negative times a positive, which is equal to a negative. We can cross cancel. 39 goes into 39 once, and 39 goes into 39 once. We're left with negative 2 times 1 over 1 times 1. And negative 2 over 1 is the same as negative 2 divided by 1, which equals negative 2. D. 2/5 times negative 3/4. This is a positive times a negative, so the answer is going to be a negative. We can cross cancel. 2 goes into 2 once, and 2 goes into 4 twice. 1 times 3 is 3, and 5 times 2 is 10. Negative 3/10. Problem number 3. Here are 2 stories. A family buys 6 tickets to a show. They also each spend $3 on a snack. They spend $24 on the show. Diego has 24 ounces of juice. He pours equal amounts for each of his 3 friends. and then adds 6 more ounces for each. Here are two equations. A. Which equation represents which story? 6 times x plus 3 equals 24 represents the family buying 6 tickets to a show and then each of them spending $3 on a snack. They spend a total of $24 on the show. The equation 3 times x plus 6 equals 24 represents Diego having 24 ounces of juice, pouring equal amounts for each of his 3 friends, and then adding 6 more ounces for each. B. What does x represent in each equation? For Diego, x represents the number of ounces of juice Diego originally poured for each friend. For the family at the show, x represents the cost of a ticket. C. Find the solution to each equation. Explain or show your reasoning. On the left in red, you have 6 times x, which is 6x, plus 6 times 3, which is 18. 6x plus 18 equals 24. And on the right-hand side in green, we have 3 times x, which is 3x, plus 3 times 6, which is 18. To get the x by itself, we need to subtract 18 from both sides of each of these equations. On the left in red, we're left with 6x equals 6. And on the right, in green, we're left with 3x equals 6. On the left in the red, we'll divide both sides by 6. 6x divided by 6 equals 1x, and 6 divided by 6 equals 1. So x equals 1. On the right-hand side in green, we'll divide both sides by 3. 3x divided by 3 is 1x, or x, and 6 divided by 3 is 2. So x equals 2. D. What does each solution tell you about its situation? This tells me that the tickets to the show cost $1 and that Diego originally poured 2 ounces of juice. Problem number 4. Here is a diagram and its corresponding equation. Find the solution to the equation and explain your reasoning. This tape diagram that's worth 24 is divided up into 6 different sections. Inside each of the sections, there's an x plus 1. That's a total of 6x plus 6. And remember, that equals 24. Look at the equation. 6 times x, that's 6x, plus 6 times 1. And that equals 24. To get the x by itself, we need to subtract 6 from both sides. 6x plus 6 minus 6 equals 6x. And 24 minus 6 equals 18. So we're left with 6x equals 18. We need to make that just 1x. So let's divide both sides by 6. X times 6 divided by 6 equals 1x, or x, and 18 divided by 6 equals 3. So x equals 3. The tape diagram is made up of 6 sections that total 24. 24 divided by 6 sections is 4. Each section has a value of 4. X plus 1 equals 4. And since 3 plus 1 equals 4, the value for x must be 3. Problem number 5 from 7th grade Unit 5, Lesson 7. Below is a set of data about temperatures. The range of a set of data is the distance between the lowest and the highest value in the set. What is the range of these temperatures? First, we need to put these temperatures in order from least to greatest. Now I can easily see that it ranges from -5 to +22. To find the distance between the lowest and the highest value, I need to subtract the lowest value from the highest value. That would be 22 minus a -5. And minus a negative is the same as the opposite of a negative. So I can rewrite this as 22 plus 5. That equals 27. So the range of these temperatures is 27. Problem number 6 from 7th grade, Unit 4, Lesson 11. A store is having a 25% off sale on all shirts. Show 2 different ways to calculate the sale price for a shirt that normally costs $24. We need to figure out what 25% of 24 is. As a decimal, 25% can be written as 0.25, and of means times, so 0.25 times 24. That equals 6, so we know that 25% of 24 is 6, and this is a 25% off sale, so we need to subtract 6 from the original price of $24. $24 minus $6 equals $18. The sale price would be $18. Here's a different way to calculate the sale price. This rectangle represents the price of the shirt, $24. Since the store is having a 25% off sale, we can divide this up into 4 groups of 25%, because that totals 100% of the price of the shirt. Since there's 4 groups, we can divide 24 by 4. And 24 divided by 4 equals 6. That means that each one of these sections is worth $6. And since each section represents 25%, that means that 25% of the price of the shirt is $6. We can substitute each section with $6. Remember, it's a 25% off sale, so we can take one of these 25% off by removing one of the sections. Now that we've taken off $6, or 25% of the price of the shirt, you can see that the sale price is $18. Don't forget to like this video and subscribe to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 6, Distinguishing Between Two Types of Situations. Problem number 1 from 7th grade Unit 6, Lesson 2. A school ordered 3 large boxes of board markers. After giving 15 markers to each of 3 teachers, there were 90 markers left. The diagram represents the situation. How many markers were originally in each box? We need to solve for x. We have x minus 15 3 times, and that totals 90. So we can write that as 3 times x minus 15 equals 90. 3 times x equals 3x minus 3 times 15, or 45. So 3x minus 45 equals 90. To get the x by itself, we need to add 45 to both sides of the equal sign. 3x minus 45 plus 45 equals 90 plus 45. So now we're left with 3x equals 90 plus 45, or 3x equals 135. Next, we need to change the 3x to just 1x, and we'll do that by dividing it by 3. So we have to divide both sides of the equal sign by 3. 3x, or x times 3, divided by 3 equals 1x, and 135 divided by 3 equals 45. There were 45 markers in each of the 3 boxes. Problem number 2 from 7th grade Unit 6, Lesson 3. The diagram can be represented by the equation 25 equals 2 plus 6x. Explain where you can see the 6 in the diagram. I see 6 right here in the 6 x's that are added to the 2 to equal 25. These 6 x's represent 6 equal parts of x. Problem number 3. Elena walked 20 minutes more than Lynn. Jada walked twice as long as Elena. Jada walked for 90 minutes. The equation 2 times x plus 20 equals 90 describes this situation. Match each amount in the story with the expression that represents it. The information tells us that Elena walked 20 minutes more than Lynn, so we can write that as E equals L plus 20. It also says that Jada walked twice as long as Elena, so we can write that as J equals 2E. Not only did Jada walk twice as long as Elena, but Jada walked for 90 minutes. We can represent that with the equation 2e equals 90. Since E equals L plus 20, Jada's walk could be represented as 2 times 20 plus L, and we know that that equals 90. Or you could represent it as 2 times L plus 20 equals 90. Either way, L represents the number of minutes that Lynn walked, and we can use an X to represent this. So A, expression X, matches with situation 3. B, X plus 20, or 20 plus X, represents 20 plus L, or L plus 20. And that matches number 2, the number of minutes that Elena walked. Let's look at the next one, C. 2 times X plus 20, or 2 times 20 plus X. That's the same as 2 times 20 plus L, or 2 times L plus 20. That represents the number of minutes that Jada walked. And since the number of minutes that Jada walked was equal to 90, situation 1 matches both expression C and D. Problem number 4. Match each equation to a story. 2 of the stories match the same equation. A. Jada's teacher fills a travel bag with 5 copies of a textbook. The weight of the bag and the books is 17 pounds. The empty travel bag weighs 3 pounds. How much does each book weigh? Think of this as 5 books times an unknown weight plus 3 pounds equals 17 pounds. Story A matches equation 4. B. A piece of scenery for the school play is in the shape of a 5-foot-long rectangle. The designer decides to increase the length. There will be 3 identical rectangles with a total length of 17 feet. By how much did the designer increase the length of each rectangle? We can think of this one as 3 rectangles times the original 5 feet long plus an additional unknown length, and the total is going to equal 17 feet. Story B matches with equation 1. 3 times an unknown length added to the original 5 feet equals 17 feet, or 3 times x plus 5 equals 17. C. Elena spends $17 and buys a $3 book and a bookmark for each of her 5 cousins. How much does each bookmark cost? We can think of this as 5 cousins times a $3 book plus an unknown price for the bookmark, and the total is $17. Story C matches with equation 3. 5 times x plus 3 equals 17. The 5 represents the cousins, the x represents the unknown price for the bookmark, and the 3 represents the $3 book. D. Noah packs up bags at the food pantry to deliver to families. He packs 5 bags that weigh a total of 17 pounds. Each bag contains 3 pounds of groceries and a packet of papers with health-related information. How much does each packet of papers weigh? He packs 5 bags, and inside each bag is a stack of papers with an unknown weight, plus 3 pounds of groceries. And this all equals 17 pounds. So I would go with equation 3. 5 times x plus 3 equals 17. E. Andre has 3 times as many pencils as Noah and 5 pens. He has 17 pens and pencils altogether. How many pencils does Noah have? 3 times as many pencils could be represented as 3x, and the 5 pens could be represented as plus 5. Altogether, the number of pens and pencils equals 17. Story E represents equation 2. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. 7th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 7, Reasoning about Solving Equations, Part 1. Problem number 1 from 7th grade Unit 2, Lesson 11. There is a proportional relationship between the volume of a sample of helium in liters and the mass of that sample in grams. If the mass of a sample is 5 grams, its volume is 28 liters. The point is shown on the graph below. A. What is the constant of proportionality in this relationship? 28 liters divided by 5 grams. The constant of proportionality is 5.6 liters per gram. B. In this situation, what is the meaning of the number you found in Part A? The volume of 1 gram of helium is 5.6 liters. C. Add at least 3 more points to the graph above and label with their coordinates. In the lower left-hand corner, you can see a point labeled at coordinates 1 and 5.6. And the next point up that I made is located at 5 and 28. Then the next one up from that is located at 10 and 56. And then finally, the last point that I made is located at 20 and 112. D. Write an equation that shows the relationship between the mass of a sample of helium and its volume. Use m for mass and v for volume. V equals 5 6/10 m. This means that the amount of volume is going to be equal to 5.6 times the mass. Problem number 2. Explain how parts of the balanced hanger compare to parts of the equation. The equation is 7 equals 2x plus 3. The stack of 7 blue blocks on the left side of the hanger represents the 7 in the equation on the left side of the equal sign. The stack of 3 blue blocks on the right side of the hanger represents the plus 3 on the right side of the equal sign of the equation. The 2 red circles on the right side of the balanced hanger represent 2x on the right side of the equal sign of the equation. The hanger represents 7 equals 2x plus 3. Problem number 3. Here is a hanger. A. Write an equation to represent the hanger. On the left side of the balanced hanger, you have 5 x's. That would be represented as 5x in an equation. Underneath the 5 x's, you have a box that says 2, so that is represented in the equation as plus 2. On the right side of the balanced hanger, you have a bar that says 17. In the equation, that means that the left side is equal to the right side and that the right side has a value of 17. B. Draw more hangers to show each step you would take to find x. Explain your reasoning. I'll start with a hanger with 5 x's plus 2 balanced with the bar that's worth 17. I want to get the x's by itself, so I need to remove 2 from the left side, but to keep it balanced, I also need to remove 2 from the right side. 5x's minus 2 equals 5x's, and 17 minus 2 equals 15. Now the balanced hanger represents an equation that would be 5x equals 15. There's 5 x's, and I can divide 15 by 5 and have 5 groups of 3, because 5 times 3 equals 15. And the hanger is still balanced. 5x divided by 5 is x, and 15 divided by 5 is 3. So 1x has a value of 3. That means that x equals 3. C. Write an equation to describe each hanger you drew. Describe how each equation matches its hanger. You can see 3 hangers here, starting with the hanger on the left. You have 5 x's plus 2, and that equals 17. The equation is written above it. 5x plus 2 equals 17. Let's move to the second hanger in the middle. We have 5 x's on the left, and it's balanced with 5 boxes, each with a value of 3 on the right. The equation would be 5x equals 15, because 5 times 3 is 15. And the hanger on the right is balanced with an x on the left side and a 3 on the right side, so the equation would read x equals 3. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. 7th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 8, Reasoning about Solving Equations, Part 2. Problem number 1. Here is a hanger. A. Write an equation to represent the hanger. Look closely at the left-hand side of the hanger. You can see a pattern. You see 2 plus x 5 different times. So you can write this as 5 times 2 plus x. And look at the right-hand side of the hanger. It's a bar that says 11. That means that 5 times 2 plus x equals 11. B. Solve the equation by reasoning about the equation or the hanger. Explain your reasoning. The first step would be divide both sides of the equal sign by 5. On the left side, we're left with 2 plus x, and on the right side of the equal sign, we're left with 11 over 5, or 11 divided by 5. And 11 divided by 5 is 2.2, or 2 2/10. Next, to get the x all by itself, we need to subtract 2 from both sides of the equal sign. X plus 2 minus 2 equals x, and 2.2 minus 2 equals 2/10. So in this case, x equals 2/10. Problem number 2. Explain how each part of the equation, 9 equals 3 times x plus 2, is represented in the hanger. On the right-hand side of the hanger, there are 3 groups of x plus 1 plus 1, which is the same as x plus 2. 9 is represented on the left-hand side of the hanger, where you have 9 groups of 1. 3 is represented by the 3 groups of x plus 2 on the right-hand side of the hanger. X plus 2. Inside each of those groups is an x plus 1 plus 1, which is equal to x plus 2. 3 times x plus 2. That's represented by the 3 groups of x plus 2. And finally, the equal sign. The equal sign is represented by the middle of the hanger. This shows that the left side is balanced or equal to the right side. Problem number 3 from 7th grade, Unit 4, Lesson 11. Select the word from the following list that best describes each situation. A. You deposit money in a savings account, and every year the amount of money in the account increases by 2.5%. This situation is describing the word interest. B. For every car sold, a car salesman is paid 6% of the car's price. This situation represents a commission. C. Someone who eats at a restaurant pays an extra 20% of the food price. This extra money is kept by the person who served the food. This situation represents a tip or a gratuity. D. An antique furniture store pays $200 for a chair, adds 50% of that amount, and sells the chair for $300. This situation represents a markup. E. The normal price of a mattress is $600, but it is on sale for 10% off. This situation represents a discount. F. For any item you purchase in Texas, you pay an additional 6.25% of the item's price to the state government. This situation represents tax. Problem number 4 from 7th grade, Unit 6, Lesson 3. Claire drew this diagram to match the equation 2x plus 16 equals 50, but she got the wrong solution as a result of using this diagram. A. What value for x can be found using the diagram? This diagram shows 2 plus x plus 16 equals 50. And x must equal 32 to make this true, because 2 plus 32 plus 16 equals 50. B. Show how to fix Claire's diagram to correctly match the equation. Go back and look at the equation at the top of the problem. 2x plus 16 equals 50. 2x means 2 times x. So Claire's diagram needs to have x written 2 times plus 16 equals 50. C. Use the new diagram to find a correct value for x. For the new diagram, the equation is 50 equals 2x plus 16. We can subtract 16 from both sides, and 2x plus 16 minus 16 equals 2x,
and 50 minus 16 equals 34. Now we know that 2x equals 34. Let's divide both sides by 2. 2x divided by 2 equals 1x, or x, and 34 divided by 2 equals 17. We know that x equals 17. D. Explain the mistake Claire made when she drew her diagram. The mistake that Claire made was she showed 2 plus x instead of 2 times x. This diagram represents 2 times x plus 16 equals 50. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 9, Dealing with Negative Numbers. Problem number 1. Solve each equation. A. 4x equals negative 28. Divide both sides by 4, and you have x equals negative 7. We can check our work. Substitute the x with a negative 7, and you have 4 times negative 7 equals negative 28, and that's true. B. X minus negative 6 equals negative 2. That's the same as x and the opposite of negative 6 equals negative 2. Since the opposite of negative 6 is positive 6, this reads as x plus 6 equals negative 2. Subtract 6 from both sides of the equal sign, and you have x equals negative 8. We can check our work. Let's substitute the x with a negative 8. Now it reads negative 8 plus 6 equals negative 2. Let's subtract 6 from both sides. Now it reads negative 8 equals negative 8, and that's true. C. Negative x plus 4 equals negative 9. Subtract 4 from both sides, and now you have negative x equals negative 13. Well, negative x also means the opposite of x. So if the opposite of x is negative 13, then positive x equals positive 13. We can check our work by substituting a 13 with the x. Since negative 13 plus 4 equals negative 9, we can be sure that x equals 13. D. Negative 3x plus 7 equals 1. First, we can subtract 7 from both sides of the equal sign. Negative 3x plus 7 minus 7 equals negative 3x, and 1 minus 7 equals negative 6. So now the equation reads negative 3x equals negative 6. To make that just one positive x, we're going to divide both sides by negative 3. Negative 3x divided by negative 3 equals positive 1x, or x, and negative 6 divided by negative 3 equals positive 2. X equals 2. We can test this out by substituting a 2 for the x. Now it reads negative 3 times 2 plus 7 equals 1. Negative 3 times 2 is negative 6. Negative 6 plus 7 equals 1. And we know that's true. So x equals 2. E. 25x plus negative 11 equals negative 86. To get rid of that negative 11, we'll add 11 to both sides of the equal sign. 25x minus 11 plus 11 equals 25x, and negative 86 plus 11 equals negative 75. Divide both sides by 25, and you get 1x, or x, equals negative 3. We can check to see if we're right by substituting the x with a negative 3. 25 times negative 3 equals negative 75, and negative 75 plus a negative 11 is the same thing as negative 75 minus 11 more, and that is negative 86. So we know that we're correct. Problem number 2. Here's an equation. 2x plus 9 equals negative 15. Write 3 different equations that have the same solution as
2x plus 9 equals negative 15. Show or explain how you found them. I can double all three terms and the x would have the same value. For example, I doubled the 2x to get the 4x, I doubled the plus 9 to get the plus 18, and I doubled the negative 15 to get negative 30. I can triple the original three terms. 2x times 3 is 6x, 9 times 3 is 27, and negative 15 times 3 is negative 45. And I could quadruple the original three terms. 2x times 4 is 8x, 9 times 4 is 36, and negative 15 times 4 is negative 60. Once again, I doubled the original terms, I tripled the original terms, and I quadrupled the original terms. For all four of these equations, the value for x is negative 12. Problem number 3 from 7th grade, Unit 6, Lesson 3. Select all the equations that match the diagram. Look closely at the diagram. You have three groups of x plus 5, and that all equals 18. Since A only has one group of x plus 5 equaling 18, it doesn't match the diagram. There should be three groups of x plus 5 equaling 18. I like equation B because 18 divided by three groups equals x plus 5 inside each group, so that one does work. So this represents 18 divided by 3, and inside each group is x plus 5. I also like equation C because it says 3 times x plus 5 equals 18, and that means three groups of x plus 5 equals 18. I also like equation D. X plus 5 equals 1/3 of 18. In other words, if you take 18 and you divide it by 3, one of those thirds is equal to x plus 5. Equation E is not a match because it says 3x plus 5 equals 18. I drew a diagram in blue that represents 3x plus 5 equals 18. And as you can see, it's different than the original diagram they gave us. Problem number 4 from 7th grade, Unit 6, Lesson 4. Match each story to an equation. A stack of nested paper cups is 8 inches tall. The first cup is 4 inches tall, and each of the rest of the cups in the stack adds 1/4 inch to the height of the stack. The stack of nested paper cups is 8 inches tall, and that equals the height of the first cup, 4 inches, plus 1/4 of an inch times the number of the rest of the cups. So story A would match equation 2, 4 plus 1/4 x equals 8. Story B. A baker uses 4 cups of flour. She uses 1/4 cup to flour the counters and the rest to make 8 identical muffins. In total, the baker uses 4 cups of flour, and that equals the 1/4 a cup of flour to flour the counters, plus an unknown amount for each of the 8 identical muffins. Story B matches equation 3. 8x plus 1/4 equals 4. Story C. Elena has an 8-foot piece of ribbon. She cuts off a piece that is 1/4 of a foot long and cuts the remainder into 4 pieces of equal length. The total length of the ribbon equals 8 feet, and she cuts off a piece that's 1/4 foot long plus an unknown length for 4 other pieces. Story C matches equation 1. 1/4 plus 4x equals 8. Problem number 5 from 7th grade, Unit 6, Lesson 2. There are 88 seats in a theater. The seating in the theater is split into 4 identical sections. Each section has 14 red seats and some blue seats. A. Draw a tape diagram to represent the situation. This tape diagram shows that there's 88 seats in total, and it's split into 4 identical sections. Inside each section, there's 14 red seats and an unknown amount of blue seats. B. What unknown amounts can be found by using the diagram or reasoning about the situation? 14 red seats times 4 sections equals 56. So we know that there are 56 red seats. 88 total seats minus 56 red seats equals 32. That tells me that there are 32 blue seats. Be sure to support my YouTube channel by liking this video, leaving a comment,
and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 10, Different Options for Solving One Equation. Problem number 1 from 7th grade Unit 4, Lesson 11. Andre wants to buy a backpack. The normal price of the backpack is $40. He notices that a store that sells the backpack is having a 30% off sale. What is the sale price of the backpack? We need to find 30% of 40. And we can do that by multiplying 30 hundredths times 40. And 0.30 times 40 equals 12. So 30% of 40 is 12. Andre gets to take $12 off of the original price. 40 minus 12 equals 28. So the sale price of the backpack is $28. Problem number 2 from 7th grade Unit 4, Lesson 12. On the first math exam, 16 students received an A grade. On the second math exam, 12 students received an A grade. What percentage decrease is that? The percent of decrease equals the difference divided by the original amount, or the difference over the original amount. 16 minus 12 gives us the difference, and the original amount was 16. That would be 4 over 16, which is equivalent to 1/4. And 1/4 can be written as 25 hundredths, which of course is 25%. The percent of decrease was 25%. Problem number 3. Solve each equation. A. 2 times x minus 3 equals 14. 2 times x is 2x, and 2 times minus 3 is minus 6. 2x minus 6 equals 14. Add 6 to both sides. Now divide both sides by 2. X equals 10. B. Negative 5 times x minus 1 equals 40. Negative 5 times x, that's negative 5x. Negative 5 times negative 1, that's a positive 5. Negative 5x plus 5 equals 40. Subtract 5 from both sides and divide both sides by negative 5. X equals negative 7. C. 12 times x plus 10 equals 24. 12 times x is 12x plus 12 times 10. That's 120. 12x plus 120 equals 24. Subtract 120 from both sides and divide both sides by 12. X equals negative 8. D. 1/6 times x plus 6 equals 11. 1/6 times x is 1/6 x, and 1/6 times 6 is 6/6. 1/6 x plus 6/6 equals 11. Since 6/6 is equal to 1, we need to subtract 1 from both sides. That leaves us with 1/6 x equals 10. So we need to multiply both sides by 6. 6 times 1/6 is 6/6 or 1, so that leaves us with x, and 10 times 6 is 60. X equals 60. E. 5/7 times x minus 9 equals 25. 5/7 times x equals 5/7 x, and 5/7 times a minus 9 equals negative 45/7. 5/7 x minus 45/7 equals 25. We need to add 45/7 to both sides. On the right-hand side of the equal sign, we need to find a common denominator. 25 can be written as 25 over 1. Let's use 7 as the common denominator. 1 times 7 is 7, and 25 times 7 is 175, and 175 plus 45 is 220. So we can rewrite this fraction as 220 over 7.
Now the equation reads 5/7 x equals 220 over 7. We need to multiply both sides by 7 over 5, and that gives us 1x, or x, equals 44. X equals 44. Problem number 4. Select all expressions that represent a correct solution to the equation 6 times x plus 4 equals 20. 6 times x is 6x plus 6 times 4. So we have 6x plus 24 equals 20. Subtract 24 from both sides, and we have 6x equals negative 4. Now we need to divide both sides by 6. That leaves us with 1x, or x, equals negative 2/3. X equals negative 2/3. We could also solve for x by dividing both sides by 6. 6 times x plus 4 divided by 6 leaves us with x plus 4. And 20 divided by 6 leaves us with 20 over 6. Subtract 4 from both sides, and you have x equals 20 over 6 minus 4, which is the same thing as x equals 20 divided by 6 minus 4. I've eliminated option A because 20 minus 4 divided by 6 is different than 20 divided by 6 minus 4. I've also eliminated option B because 1/6 of 20 minus 4 is different than 20 divided by 6 minus 4. And I can eliminate option C because 20 minus 6 minus 4 is different than 20 divided by 6 minus 4. I'm going to keep option D because option D is the same as 20 divided by 6 minus 4, which is equivalent to 20 over 6 minus 4. I can also keep expression E because 20 minus 24 is negative 4, and 1/6 of negative 4 is equivalent to negative 4/6. And finally, I can keep expression F because 20 minus 24 is negative 4, and negative 4 divided by 6 is equivalent to negative 4 divided by 6, or negative 4 over 6. Problem number 5. Lynn and Noah are solving the equation 7 times x plus 2 equals 91. Lynn starts by using the distributive property. Noah starts by dividing each side by 7. A. Show what Lynn and Noah's full solution methods might look like. On the left side, I'll use the distributive property like Lynn, and on the right side, I'll divide both sides by 7. B. What is the same and what is different about their methods? They both divided by 7, and x equals 11. Lynn subtracted both sides by 14, and Noah subtracted both sides by 2. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 11, Using Equations to Solve Problems. Problem number 1 from 7th grade, Unit 5, Lesson 9. Find the value of each variable. A times 3 equals negative 30. Since negative 10 times 3 equals negative 30, A equals negative 10. Let's check our answer. Negative 30 divided by 3 equals negative 10. So negative 10 times 3 equals negative 30. B. Negative 9 times B equals 45. Since negative 9 times negative 5 equals positive 45, then B equals negative 5. Let's double check. 45 divided by negative 9 equals negative 5. So B equals negative 5. C. Negative 89 times 12 equals C. Well, a negative times a positive equals a negative, and 89 times 12 equals 1068. So C equals negative 1068. D. D times 88 equals negative 88,000. Negative 88,000 divided by positive 88 equals D. And since negative 88,000 divided by 88 equals negative 1,000, then D equals negative 1,000. Let's double check. Negative 1,000 times 88 equals negative 88,000. So we're correct. D equals negative 1,000. Problem number 2. Match each equation to its solution and to the story it describes. A. 5x minus 7 equals 3. We need to add 7 to both sides of the equal sign. That leaves us with 5x equals 10. Next, we're going to divide both sides by 5. That leaves us with 1x, or x, equals 2. Since x equals 2, the solution for equation A would be the third solution, because its value is 2. I think the story described by equation A is the club activity story. It puts members into 5 groups. After 7 students left, that would be the minus 7. There are only 3 students left to finish the activity. That would be equals 3. The how many students were in each group, that would be x. The 5x represents 5 groups of 2 students. That would be 10 students. When 7 students leave, that would be 10 minus 7, or 3. B. 7 equals 3 times 5 plus x. We can rewrite that as 7 equals 15 plus 3x. Next, we have to subtract 15 from both sides. That leaves us with negative 8 equals 3x. Finally, we'll divide both sides by 3. That leaves us with negative 8 over 3 equals x, or x equals negative 8 thirds. The solution to equation B would be the second solution, negative 8 thirds. I think that the story described by equation B is the story about building guitars. In the story, it says now it takes 7 hours to build 3 guitars. That's the 7 in the equation. The story also mentioned that before the reduction in time, it took 5 hours to build 1 guitar. That's the 5 in the equation. And the x in the equation represents the last sentence in the story. By how much did they reduce the time it takes to build each guitar? Since x equals negative 8 thirds, that means that they reduce the amount of time that it takes to build each guitar by 8 thirds. The term reduce means that they're subtracting 8 thirds from the time it used to take to build 1 guitar. C. 3x plus 5 equals negative 7. First, we need to subtract 5 from both sides. That leaves us with 3x equals negative 12. Finally, we divide both sides by 3. That leaves us with 1x, or x, equals negative 4. So x equals negative 4. The solution for equation C is the first solution, negative 4. The story that best matches equation C is the temperature story. The first line in the story says the temperature is negative 7, and that's represented in the equation by equals negative 7. In the second line of the story, it says that the temperature tripled. Tripled is represented in the equation by the 3, and the temperature is represented in the equation by the x. 3x means 3 times the temperature, or triple the temperature. It also mentions that the temperature rose 5 degrees, and that's represented in the equation with plus 5. Finally, equation D. 1/3 times x plus 7 equals 5. My first thought was to multiply 1/3 times x plus 1/3 times 7. That would have left me with 1/3 x plus 7/3 equals 5. Then I would have had to have subtracted 7/3 from both sides, which means I would have had to subtract 7/3 from 5. And then I thought of an easier way to solve for x. By turning the 1/3 into a 1, by making it 3 times greater. That means I have to multiply both sides by 3. 1/3 times 3 and 5 times 3. That leaves me on the left-hand side with 1 times x plus 7, which is the same as x plus 7. And on the right-hand side, 5 times 3, which is 15. So now the equation reads x plus 7 equals 15. And finally, we subtract 7 from both sides, and we have x equals 8. The solution for equation D is the fourth solution, 8. The story that equation D describes is the roses story. It says in the story that Jada has 7 pink roses. Those 7 pink roses are represented in the equation by the positive 7 or the plus 7 located inside the parentheses. Then it goes on to say that she has some white roses. That's an unknown number which is represented in the equation with the variable x. And then it says that she gave all of them away to each of her 3 favorite teachers. That means that all these roses were divided among 3 different teachers, and that's represented by the 1/3 on the outside of the parentheses. It said that there were 5 roses given to each of those 3 teachers, and those 5 roses are represented by the equals 5 in the equation. Problem number 3. The baby giraffe weighed 132 pounds at birth. He gained weight at a steady rate for the first 7 months until his weight reached 538 pounds. How much did he gain each month? We could use the equation y equals mx plus b to find out how much weight he gained each month, with y equal to the total number of pounds after 7 months, which is 538 pounds. M is the unknown weight gained per month. X is the number of months, which is 7, so we can substitute a 7 for x. And B would be the weight at birth. We can substitute the B with 132 pounds, or 132. Next, we can subtract 132 from both sides of the equal sign, and that leaves us with 406 equals 7m. Finally, we can divide both sides by 7, and that leaves us with m equals 58. That means that each month the baby giraffe gained 58 pounds. Problem number 4. 6 teams are out on the field playing soccer. The teams all have the same number of players. The head coach asked for 2 players from each team to come help him move some equipment. Now there are 78 players on the field. Write and solve an equation whose solution is the number of players on each team. Here's my equation. The 6 stands for the 6 teams that are playing soccer on the field. The x stands for the unknown amount of players on each team. The -2 represents 2 players from each team leaving the field to help the coach move some equipment. And the 78 represents the number of players altogether who remain on the field playing soccer. Let's divide both sides by 6 so that we have x minus 2 on the left and 78 divided by 6 on the right. That leaves us with x minus 2 equals 13. Finally, we can add 2 to both sides. That leaves us with x equals 15. That means that each team has 15 players. Problem number 5 from 7th grade, Unit 4, Lesson 7. A small town had a population of 960 people last year. The population grew to 1,200 people this year. By what percentage did the population grow? This is like a double number line with the number of people across the top and the percentage across the bottom. The population stretched from 960 to 1,200. We have to find the difference. 1,200 minus 960 is 240. And 240 divided by 960 is equivalent to 1/4, or 0.25, which is 25 hundredths. 25 hundredths is equivalent to 25%. So this was an increase of 25%. That means that the population grew by 25%. We can also use the double number line to help us easily find the answer. We know that 100% of the population was 960. So we can find 960, and then underneath it we can write 100%. 50% of 960 would be 480, so we can find 480, and underneath that we can write 50%. We know that half of 50% is 25%, and half of 480 is 240. So underneath 240, we can write 25%. Since the difference between 1200 and 960 is 240, and 240 is 25% of 960, we know that the population grew by 25%. Problem number 6 from 7th grade, Unit 4, Lesson 7. The gas tank of a truck holds 30 gallons. The gas tank of a passenger car holds 50% less. How many gallons does it hold? That would be 50% of 30 gallons. We can rewrite this as 0.50 times 30. And of course, that equals 15. That means that the gas tank of a passenger car holds 15 gallons of gas. 50% of 30 also means half of 30. And since 15 is half of 30, then we know that the passenger car's gas tank holds 15 gallons of gas. We can also figure this out easily by using the double number line. We know that 100% of the tank is 30 gallons. So above 100%, we can write 30 gallons. Since the passenger car holds 50% less, basically we need to find 50% of 30. Well, we know that halfway between 0% and 100% is 50%. So to find 50% of 30, we need to find the number that's halfway between 0 and 30. That would be 15. So above 50%, we can put a 15. This tells us that the passenger car's gas tank holds 15 gallons of gas. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 12, Solving Problems About Percent, Increase or Decrease. Problem number 1 from 7th grade, Unit 4, Lesson 12. A backpack normally costs $25, but it is on sale for $21. What percentage is the discount? The discount price divided by the original price will tell us the percent paid for the sale price. And 21 divided by 25 is 84 hundredths, which is 84%. To find the percentage of the discount, we need to subtract 84% from 100%. 100 minus 84 equals 16. That means the sale is a 16% discount. Problem number 2 from 7th grade, Unit 5, Lesson 9. Find each product. A. 2/5 times -10. We can simplify. 5 goes into 5 once, and 5 goes into -10 twice, so that becomes a -2. Now we multiply straight across. 2 times -2 is -4, and 1 times 1 is 1. That leaves us with -4 over 1, which is the same as -4. B. -8 times -3 over 2. We can rewrite that as -8 over 1 times -3 over 2. And we can simplify. 2 goes into 2 once, and 2 goes into -8 4 times. So that becomes -4. Now multiply straight across. A negative times a negative equals a positive, and 4 times 3 equals 12. And on the bottom, 1 times 1 equals 1. So we have positive 12 over 1, which is the same as 12. C. 10/6 times 6/10. We can write them both as fractions. 10 over 6 times 6/10, or 6 over 10. We can cross cancel. 6 goes into 6 once, and 6 goes into 6 once, and 10 goes into 10 once, and 10 goes into 10 once. You can already tell this is going to equal 1 because 1 times 1 on top is 1, and 1 times 1 on the bottom is 1, which is 1 over 1, or 1 divided by 1, which equals 1. D. -100 over 37 times -37 hundredths. Again, we can write them both as fractions. -100 over 37 times 37 over -100. You can already tell that this answer is going to be positive 1 because negative 3700 over negative 3700 equals positive 1. Problem number 3. Select all expressions that show x increased by 35%. That means a 35% increase of a number, and we can write that as 0.35 times x, that shows the increase of the number, plus x, the original number. We can also write it as 1.35 times x. We can also think of it as 35 hundredths times x plus 1 times x, the original x, and that can be written as a fraction as well. 35 over 100 times x plus the original x. We can also write the plus x as plus 100 over 100 times x, because that's the same as 1x. My point is, there's a lot of expressions that can show x increased by 35%. Take a look at expression A, 1.35x. That's an expression that we came up with, and we can choose that one. Take a look at expression B, 35 over 100 times x. That's just part of one of our expressions. We would have had to have added another x to this one, so we can't choose B. Take a look at expression C, x plus 35 over 100 times x. That's the same as 35 over 100x plus x, so we can choose C. Let's look at expression D, 1 plus 0.35 times x. That's the same as x times 0.35 plus 1. So we can choose expression D. Take a look at expression E, 100 plus 35 over 100 times x. That's equivalent to expression A, 1.35 times x. So we can choose expression E. And finally, expression F, 100 plus 35 times x. That's equivalent to 135 times x, which is 100 times greater than expression A, so we cannot choose expression F. Problem number 4 from 7th grade, Unit 4, Lesson 11. Complete each sentence with the word discount, deposit, or withdrawal. A. Claire took $20 out of her bank account. She made a withdrawal. B. Kieran used a coupon when she bought a pair of shoes. She got a discount. C. Priya put $20 into her bank account. She made a deposit. D. Lynn paid less than usual for a pack of gum because it was on sale. She got a discount. Problem number 5. Here are two stories. The initial freshman class at a college is 10% smaller than last year's class. But then, during the first week of classes, 20 more students enroll. There are then 830 students in the freshman class. A store reduces the price of a computer by $20. Then, during a 10% off sale, a customer pays $830. Here are two equations. A. Decide which equation represents each story. The first story says that the freshman class is 10% smaller than last year's class, so we can write that as x minus 10% times x. The x represents the freshman class, and x minus 10% of x means this year's freshman class is 10% smaller than last year's freshman class. There are then 830 students in the freshman class. We can write this as 830 equals x minus 10% of x plus 20. The plus 20 in the equation represents the 20 students that enrolled during the first week of class in the story. Look at the x in the equation. We could actually call that 100% of x. Now we have 100% of x minus 10% of x. And 100% minus 10% equals 90%. So we can think of this as 90% x plus 20 equals 830. Since the decimal value of 90% is 0.9, for this story I would go with the equation 0.9x plus 20 equals 830. The next story, where the store reduces the price of a computer by $20, then during a 10% off sale, a customer pays $830, I could write the equation 90% times x minus 20 equals 830. And remember, 90% as a decimal would be 0.9. So I would use the equation 0.9 times x minus 20 equals 830 for this story. B. Explain why one equation has parentheses and the other doesn't. In the second story, the store reduced the price of the computer by $20. They did that first. Then they had a 10% off sale, which means they were going to charge 90% of the value of the computer after they reduced the price by $20. They represented this in the equation using parentheses, x minus 20. And that was a little different compared to the first story. In the first story, they took 90% of last year's class, and then they added 20 students. They didn't need parentheses to separate this. C. Solve each equation and explain what the solution means in the situation. The first equation, 9/10 x plus 20 equals 830. Subtract 20 from both sides of the equal sign. Now you're left with 9/10 x equals 810. Divide both sides by 9/10 and you're left with x equals 900. 900 represents the number of students in the freshman class. For the second equation, divide both sides by 0.9. Then you're left with x minus 20 equals 922.2. Add 20 to both sides of the equal sign, and you get x equals 942.22. 942.22 represents the price of the computer before discounts. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 13, Reintroducing Inequalities. Problem number 1. For each inequality, find two values for x that make the inequality true and two values for x that make it false. A. X plus 3 is greater than 70. Subtract 3 from both sides of the inequality sign, and that leaves you with x is greater than 67. Values for x that would make the inequality true would be anything larger than 67. For example, x could equal 70 or x could equal 80, anything greater than 67. Values for x that would make the inequality false would be any values that are not greater than 67. For example, x could be 65 or x could be 1. Anything with a value that's not greater than 67. B. X plus 3 is less than 70. Subtract 3 from both sides of the inequality sign, and you're left with x is less than 67. Values for x that would make this inequality true would be any values that are less than 67. For example, x could be 30 or x could be 10. Anything less than 67. Values for x that would make this inequality false would be any values that are not less than 67. For example, x could be 90 or x could be 100. Anything not less than 67 would make this inequality false. C. Negative 5x is less than 2. Divide both sides by negative 5. Since a negative divided by a negative is a positive, you're left with a positive x. And on the right-hand side, you have a positive divided by a negative, so you're left with a negative 2 over 5. Notice when we divided both sides by negative 5, the x became a positive. When we did that, we needed to change the inequality sign from a less than to a greater than. X is greater than negative 2/5. Values for x that would make this inequality true would be any value for x that was greater than negative 2/5. For example, x could equal 30 or x could equal 3/5. Values for x that would make this inequality false would be any values that were not greater than negative 2/5. For example, x could be negative 90 or x could be negative 2/5, because negative 2/5 is not greater than negative 2/5. D. 5x is less than 2. Divide both sides by 5 and you're left with x is less than 2/5. Values for x that would make this inequality true would be any values that were less than 2/5. For example, the value for x could be negative 30 or the value for x could be negative 3/5. Any value would work as long as it was less than 2/5. Values for x that would make this inequality false would be any values for x that were not less than 2/5. For example, if x were 90 or x were 2/5, the inequality would be false because 90 is not less than 2/5 and 2/5 is not less than 2/5. Problem number 2. Here is an inequality. Negative 3x is greater than 18. A. List some values for x that would make this inequality true. The first step would be to divide both sides by negative 3. That would get the x by itself, and it would be a positive x. Since the x is now positive, we're going to have to change the inequality sign from a greater than to a less than. Now you're left with x is less than negative 6. You can list any values for x that are less than negative 6. Negative 7, negative 8, negative 9, negative 10, any of those values would work, as long as the values were less than negative 6. B. How are the solutions to the inequality negative 3x is greater than or equal to 18 different from the solutions negative 3x is greater than 18? Explain your reasoning. First, let's divide both sides by negative 3. That leaves us with x is less than negative 6 and x is less than or equal to negative 6. The difference is x is less than negative 6, the x can't equal negative 6. Whereas x is less than or equal to negative 6, x can equal negative 6. Problem number 3. Match each sentence with the inequality that could represent the situation. A. Han got $2 from Claire, but still has less than $20. X could represent the amount of money that Han has, so x plus $2 is less than 20. That matches with inequality 3. X plus 2 is less than 20. B. Mai spent $2 and has less than $20. X could represent the amount of money that Mai has, and this would be x minus 2 is less than $20. Sentence B matches inequality 1. C. If Tyler had twice the amount of money he has, he would have less than $20. Twice the money he has would be 2 times x, and 2 times x would be less than $20, so the inequality would be 2x is less than 20. Sentence C matches inequality 2. 2x is less than 20. And finally, D. If Priya had half the money she has, she would have less than $20. Half the money, that would be 1/2 x. And 1/2 x would be less than $20, or 1/2 x is less than 20. Inequality 4 matches with sentence D. Problem number 4 from 7th grade, Unit 4, Lesson 12. Here are the prices for cheese pizza at a certain pizzeria. A. If you had a coupon that made the price of a large pizza $13, for what % off was the coupon? The regular price of a large cheese pizza is $16.25. Subtract $13 from that, and the coupon saves you $3.25. $3.25 divided by $16.25 equals 2/10 or 20/100, which is 20%. So the coupon saved 20%. B. Your friend purchased a medium pizza for $10.31 with a 30% off coupon. What is the price of a medium pizza without a coupon? The unknown price of a medium pizza minus the price he paid divided by the unknown price of a medium pizza equals 0.30, or the discount he got by using the 30% off coupon. Let's get rid of the divided by x by multiplying both sides by x. Now you're left with x minus 10.31 equals 0.30 times x. Subtract x from both sides and you're left with negative 10 and 31 hundredths equals 30 hundredths x minus 1x. We need to find the difference between negative 1x and 30 hundredths x. I could write minus 1x like minus 100 hundredths x. So we have 30 hundredths x minus 100 hundredths x. And that's a difference of negative 70 hundredths x, or negative 7/10 x. We can rewrite the equation as negative 10 and 31 hundredths equals negative 7/10 x. Divide both sides by negative 7/10 and you're left with x equals approximately 14 and 73 hundredths. C. Your friend has a 15% off coupon and $10. What is the largest pizza your friend can afford, and how much money will be left over after the purchase? Let's take 15% off of the smallest pizza price. That's $11.60. 15% can be rewritten as 0.15. So we can write 15 hundredths times 11 and 60 hundredths. That's 1 and 74 hundredths, which means the 15% savings on a pizza that cost $1.60 is $1.74. So $1.60 minus $1.74. That equals $9.86. $10 minus $9.86 equals 14 cents. So the amount of change that they get back would be 14 cents, and the largest pizza that the friend could buy would be the small pizza. Problem number 5, from 7th grade Unit 6, Lesson 4. Select all the stories that can be represented by the diagram. The entire diagram has a value of 7. It has 3 x's and a value of 1 unit. That could be 3 times x plus 1 equals 7. Let's look at the first story. A. Andre spends 7 hours this week for end-of-year exams. He spends 1 hour on English and an equal number of hours on math, science, and history. The 1 unit in the diagram could represent 1 hour on English, and the 3 x's could represent the equal number of hours on math, science, and history. So yes, this diagram represents story A. Let's look at story B. Lynn spends $3 on 7 markers and $1 on a pen. 3 times 7 plus 1. That's a total of 22, not 7. So the diagram doesn't represent story B. Let's look at story C. Diego spends $1 on 7 stickers and 3 marbles. I would disagree because the diagram looks like Diego spent $7 on 3 marbles and 1 sticker. Let's look at D. Noah shares 7 grapes with 3 friends. He eats 1 and gives each friend the same number of grapes. The 3 x's represent the equal amount given to the 3 friends, and the 1 unit represents the 1 grape that he ate. So the diagram matches story D. Let's look at story E. Elena spends $7 on 3 notebooks and a $1 pen. The 3 x's in the diagram represent the 3 notebooks, and the 1 unit in the diagram represents the dollar pen. So the diagram represents story E. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. 7th grade Open Up Resources Illustrative Mathematics, Unit 6, Lesson 14, Finding Solutions to Inequalities in Context. Problem number 1. The solution to 5 minus 3x is greater than 35 is either x is greater than negative 10 or negative 10 is greater than x. Which solution is correct? Explain how you know. The correct solution is negative 10 is greater than x. And here's why. Subtract 5 from both sides of the inequality, and you're left with negative 3x is greater than 30. Divide both sides of the inequality by negative 3. When you're changing this value of x from negative to positive, you also change the inequality sign. In this case, it changes from a greater than to a less than. And that leaves you with x is less than negative 10, which can be rewritten as negative 10 is greater than x. So the solution to this inequality is negative 10 is greater than x. Problem number 2. The school band director determined from past experience that if they charge $T for a ticket to the concert, they can expect attendance of 1,000 minus 50 times T. The director used this model to figure out that the ticket price needs to be $8 or greater in order for at least 600 to attend. Do you agree with this claim? Why or why not? The band director is using the model 1,000 minus 50 times T, and T is the price of the ticket. So in this case, we can substitute T with $8 or greater. We can test this model out by substituting T with $8 and then substituting T with a larger amount. When we substitute T with 8, it now reads 1,000 minus 50 times 8. 50 times 8 is 400, so it reads 1,000 minus 400. And 1,000 minus 400 is 600. So far it checks out. Now let's substitute the T with something greater than $8, like $8.50. 1,000 minus 50 times $8.50. That's the same as 1,000 minus 425. Since 1,000 minus 425 is 575, and 575 is less than 600, then I don't agree with the band director. Let's test it out by changing the ticket price to something less than $8. Let's use $5.50. So the model now reads 1,000 minus 50 times $5.50. Since 50 times $5.50 equals 275, the model now reads 1,000 minus 275. And 1,000 minus 275 is 725. And 725 is greater than 600. That tells me that the price of the tickets has to be $8 or less in order for at least 600 people to attend. Problem number 3 from 7th grade Unit 6, Lesson 13. Which inequality is true when the value of x is negative 3? A. Negative x minus 6 is less than negative 3.5. When we substitute the x with a negative 3, this now reads negative 3, or the opposite of negative 3, minus 6 is less than negative 3.5. Since a negative times a negative is a positive, we can rewrite this as positive 3, or 3 minus 6 is less than negative 3.5. Since 3 minus 6 is negative 3, the inequality now reads negative 3 is less than negative 3.5. And that's not true, because negative 3 is closer to 0 on the number line compared to negative 3.5. So negative 3 is actually greater than negative 3.5. B. Negative x minus 6 is greater than 3.5. Let's substitute the x with a negative 3. Now the equation reads negative times negative 3 minus 6 is greater than 3.5. Since a negative times a negative is a positive, we can rewrite this as 3 minus 6 is greater than 3.5. 3 minus 6 is negative 3. So this now reads negative 3 is greater than 3.5, which is not true, because negative 3 is actually less than 3.5. C. Negative x minus 6 is greater than negative 3.5. Let's substitute the x with a negative 3. Now the inequality reads negative times a negative 3 minus 6 is greater than negative 3.5. Since a negative times a negative is a positive, this becomes a positive 3 minus 6 is greater than negative 3.5. Since 3 minus 6 is negative 3, and negative 3 is greater than negative 3.5, then this is true. Remember, negative 3 is closer to the 0 on a number line than negative 3.5. So negative 3 is greater than negative 3.5. So for inequality C, the value for x is negative 3. D. X minus 6 is greater than negative 3.5. Let's substitute the x with a negative 3. Now the inequality reads negative 3 minus 6 is greater than negative 3.5. Since negative 3 minus 6 is negative 9, and negative 9 is not greater than negative 3.5, then this is not true. For D, the value for x is not negative 3. C is the only inequality that's true when the value for x is negative 3. Problem number 4 from 7th grade, Unit 6, Lesson 13. Draw the solution set for each of the following inequalities. A. X is less than or equal to 5. Since we're talking about 5, I can circle it, but it says that x is less than or equal to. So we need to bubble in that circle. Fill in the circle to represent equal to, so in this case it's going to be equal to or less than 5. That means that the arrow on the number line needs to point to the left to represent all the numbers that are less than or equal to 5. The inequality sign actually helps you identify which way the arrow is going to point on the number line. Look at this inequality sign. It's a less than or equal to, which happens to be pointing towards the left. That means that your arrow is going to point towards the left on the number line. B. X is less than 5 over 2. That's equivalent to x is less than 2.5. Locate 2.5 and circle it. This time we're not going to bubble it in because it's not less than or equal to, it's only less than. So we'll keep it just a circle without filling it in. Now look at the inequality sign, the less than sign. It's pointing to the left. That means that the arrow on the number line also will point to the left. Take a look at this example. When graphing this inequality, you'll circle 2.5 or 2.5, and then the arrow will point to the left. That represents all the numbers that are less than 2.5. Problem number 5 from 7th grade, Unit 6, Lesson 3. Write 3 different equations that match the tape diagram. This rectangle represents 19 plus these 7 boxes, each with one x inside. That represents plus 7x. So far we have 19 plus 7x. 40 represents the entire amount. That means that 19 plus 7x equals 40. This is one example of an equation that matches the tape diagram. We can rewrite that equation as 40 equals 7x plus 19. That also represents the tape diagram. And we can subtract 19 from each side of the equal sign to find another equation that matches the tape diagram. Problem number 6 from 7th grade, Unit 6, Lesson 2. A baker wants to reduce the amount of sugar in his cake recipes. He decides to reduce the amount used in one cake by 1/2 cup. He then uses 4.5 cups of sugar to bake 6 cakes. A. Describe how the tape diagram represents the story. You can see that there's 6 boxes, and inside each of those 6 boxes is x minus 1/2. And underneath the 6 boxes, it says that the total amount is worth 4.5. The x in the tape diagram and the x in my equation represent each cake. The minus 1/2 represents removing 1/2 cup of sugar from that cake. The 4.5 represents the total of cups of sugar used to make all 6 cakes. B. How much sugar was originally used in each cake recipe?
To figure this out, all we have to do is solve for x. 6 times x is 6x, and 6 times negative 1/2 is negative 3. So now the equation reads 6x minus 3 equals 4.5. Add 3 to both sides, and you have 6x equals 7.5. Divide both sides by 6, and you have x equals 7.5 divided by 6, which is 1 1/4 or 1 1/4. That means that in the original recipe, each cake had 1 1/4 cups of sugar in it. Problem number 7 from 7th grade, Unit 4, Lesson 12. 1 year ago, Claire was 4 feet 6 inches tall. Now Claire is 4 feet 10 inches tall. By what percentage did Claire's height increase in the last year? A year ago, Claire was 4 feet 6 inches tall. That's equal to 54 inches. Now Claire is 4 feet 10 inches tall. That's equal to 58 inches. The difference between her height this year and her height last year divided by her height last year will tell us the percentage that Claire's height increased over the past year. 58 minus 54 is 4, and 4 divided by 54 is approximately 0.0740, which is approximately 7.4%. That means that Claire's height increased approximately 7.4% over the past year. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 15, Efficiently Solving Inequalities. Problem number 1. A. Consider the inequality -1 is less than or equal to x divided. Seventh grade Open Up Resources, Illustrative Mathematics, Unit 6, Lesson 15, Efficiently Solving Inequalities. Problem number 1. A. Consider the inequality -1 is less than or equal to x divided by 2. Predict which values of x will make the inequality true. We could make it an x rather than x over 2 by multiplying both sides by 2. X divided by 2 times 2 equals x, and -1 times 2 equals -2. Now the inequality reads -2 is less than or equal to x. And that's the same as x is greater than or equal to -2. We can substitute values for x into this inequality. -1 is less than or equal to x divided by 2. For example, let's put a -2 here. We can substitute the x with a -2. Now it reads -2 divided by 2. That's -1. So -1 is less than or equal to -1. And that's true. The value of x, -2, is greater than or equal to -2. I predict that the values for x that will make this inequality true will be all values that are equal to or greater than -2. Complete the table to check your prediction. Let's start with -4. We can substitute the x with the -4, and we have -4 divided by 2. That's -2. -1 is not less than or equal to -2. When the value of x is -4, it is not greater than or equal to -2. So this is false. Let's substitute the x with the -3. Now we have -3 divided by 2. That equals -1.5. -1 is not less than or equal to -1.5. When the value for x is -3, it is not greater than or equal to -2. So this is false. All the rest of the values for x in the table will make the inequality true. We already did -2, so let's do -1. -1 divided by 2 is -1/2. And -1 is less than or equal to -1/2. So this is true. We can also look at it like this. -1 is greater than or equal to -2.
Let's do 0. 0 divided by 2. That's 0. And negative 1 is less than or equal to 0, so this is true. Let's do 1. 1 divided by 2 is 1/2, and negative 1 is less than or equal to 1/2, so this is true. Let's do 2. 2 divided by 2 is 1, and negative 1 is less than or equal to 1, so this is true. Let's do 3. 3 divided by 2 is 1.5, and negative 1 is less than or equal to 1.5, so this is true. And finally, let's do 4. 4 divided by 2 is 2, and negative 1 is less than or equal to 2, so this is true. B. Consider the inequality. 1 is less than or equal to negative x over 2. Predict which values of x will make it true. This time, we'll multiply both sides by negative 2. Negative x over 2 times negative 2 is x, and 1 times negative 2 is negative 2. And since I multiplied by a negative, I switched the inequality sign. Now it reads negative 2 is greater than or equal to x, which is the same thing as x is less than or equal to negative 2. So my prediction is that the value for x that will make this true will be all values that are less than or equal to negative 2. And on this table, that would be a negative 2, a negative 3, and negative 4. Complete the table to check your prediction. We need to divide all the values of x by negative 2. Next, substitute the values of x for the numerator of each of these fractions. We can change these to positive because a negative divided by a negative is a positive. 4 divided by 2 is 2. 3 divided by 2 is 1.5. 2 divided by 2 is 1. 1 divided by 2 is 1/2. 0 divided by negative 2 is 0. 1 divided by negative 2 is negative 1/2. 2 divided by negative 2 is negative 1. 3 divided by negative 2 is negative 1.5. And 4 divided by negative 2 is negative 2. Let's check out my prediction. Remember, the inequality is 1 is less than or equal to negative x divided by 2. Look underneath the negative 4 on the chart. There's a 2. So now we can say 1 is less than or equal to 2. And since that's true, our prediction was correct. Let's do the same thing for negative 3. Underneath the negative 3 is a 1.5. 1 is less than or equal to 1.5, and that's true. Look underneath the negative 2 in the chart. There's a 1. 1 is less than or equal to 1, and that's also true. Look underneath negative 1. There's a 1/2. So let's say 1 is less than or equal to a 1/2, and that's not true. Same thing with 0. 1 is less than or equal to 0. That's not true. The rest of these on the right are also not true. Problem number 2. Diego is solving the inequality 100 minus 3x is greater than or equal to negative 50. He solves the equation 100 minus 3x equals negative 50 and gets x equals 50. What is the solution to the inequality? Since our x is positive now, we have to remember to change the inequality symbol. So now it reads x is less than or equal to 50. Here's how I got that. I subtracted 100 from both sides. That left me with negative 3x is greater than or equal to negative 150. Then I divided both sides by negative 3. And dividing by a negative, I have to change the inequality sign. Now the answer reads x is less than or equal to 50. So that would be inequality B. Problem number 3. Solve the inequality. Negative 5 times x minus 1 is greater than negative 40. And graph the solution on a number line. Negative 5 times x is negative 5x, and negative 5 times negative 1 is a positive 5. So we have negative 5x plus 5 is greater than negative 40. Subtract 5 from both sides, and now you have negative 5x is greater than negative 45. divide both sides by -5, and change the inequality sign. And you're left with x is less than 9. The inequality sign shows you the direction that the arrow is going to be pointed. So if you look at this blue inequality sign and imagine that it's an arrow pointing to the left, the arrow that you'll use on the graph will also point to the left. And since the value of x is anything less than 9, you're only going to use a circle at the 9. Do not bubble it in. If you bubble it in, it means it's equal to or less than. Problem number 4 from 7th grade, Unit 6, Lesson 13. Select all the values of x that make the inequality true. Negative x plus 6 is greater than or equal to 10. We'll have to subtract 6 from both sides, and we're left with negative x is greater than or equal to 4. Multiply both sides by -1 and switch the inequality sign, and you'll have positive x is less than or equal to -4. That means that we can select all values for x that are less than -4 or equal to -4. And you can see here that I bubbled in the graph to show that it's also equal to -4, and that the graph points to the left, just like the inequality sign did. Problem number 5 from 7th grade, Unit 6, Lesson 13. Draw the solution set for each of the following inequalities. A. X is greater than 7. First, I need to circle 7, and then I'm going to draw the arrow in the direction that the inequality is pointing. So this arrow is going to go to the right. The solutions are the numbers larger than 7, not equal to 7 and not less than 7, but larger than 7. B. In this case, the values for x are greater than or equal to -4.2. So not only am I going to circle -4.2, but I'm going to bubble it in because it says or equal to. And it's going to point to the right because these are values that are greater than or equal to -4.2. Problem number 6 from 7th grade, Unit 4, Lesson 12. The price of a pair of earrings is $22, but Priya buys them on sale for $13.20. A. By how much was the price discounted? The original price of $22 minus the sale price, $13.20, equals the discount, $8.80. B. What was the percentage of the discount? $8.80 divided by $22 equals 40/100ths, which is 40%. That means that $8.80 is 40% of $22. Be sure to support my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks for watching, and I'll see you next time. Seventh grade Open Up Resources, Illustrative Mathematics. Unit 6, Lesson 16, Interpreting Inequalities. Problem number 1. Priya looks at the inequality 12 minus x is greater than 5 and says, I subtract a number from 12 and want a result that is bigger than 5. That means that the solutions should be values of x that are smaller than something. Do you agree with Priya? Explain your reasoning and include solutions to the inequality in your explanation. Yes, I agree, and let me show you why. 12 minus x is greater than 5. Subtract 12 from both sides. That gives you negative x is greater than -7, so we'll have to multiply or divide both sides by -1. When we do that, we'll have to change the inequality sign. So now it reads, positive x is less than positive 7. X represents all the solutions less than 7. Problem number 2. When a store had sold 2/5 of the shirts that were on display, they brought out another 30 from the stockroom. The store likes to keep at least 150 shirts on display. The manager wrote the inequality 3/5 times x plus 30 is greater than or equal to 150 to describe the situation. A. Explain what 3/5 means in the inequality. 3/5 represents the remaining shirts on display after 2/5 of the shirts on display were sold. B. Solve the inequality. First, subtract 30 from both sides of the inequality. Then you're left with 3/5 times x is greater than or equal to 120. Next, to make it 1x, we need to multiply by the reciprocal of 3/5. 5/3 times 3/5 times x equals 1 times x, or x. And 120 times 5/3 equals 200. The solution is x is greater than or equal to 200. C. Explain what the solution means in this situation. The solution means that there were 200 or more shirts originally on display. Problem number 3 from 7th grade, Unit 6, Lesson 13. You know x is a number less than 4. Select all the inequalities that must be true. Since x is a number that's less than 4, any value that's less than 4 could be equal to x. On a number line, that would be any value to the left of 4, not including 4. Take a look at A. X is less than 2. That's like saying all the values of x must be less than 2, and that's not necessarily true because originally it was all the values of x must be less than 4. Since there's values between 2 and 4 that could also be true, then A is not true. The values for x do not have to be less than 2. They have to be less than 4. Let's take a look at B. X plus 6 is less than 10. Subtract 6 from both sides and you're left with x is less than 4. And that's true. X is less than 4. Because the original inequality said, you know x is a number less than 4. Let's take a look at C. 5x is less than 20. Divide both sides by 5 and you're left with x is less than 4. And that's true because the original inequality is x is less than 4. Take a look at D. X minus 2 is greater than 2. Add 2 to both sides and you have x is greater than 4. And this is not true because the original inequality was x is less than 4. And the solution for D is x is greater than 4. Take a look at E. X is less than 8. This is not true because 5, 6, and 7 are all less than 8, but they're greater than 4. So all values that are less than 8 are not necessarily less than 4. Problem number 4. From 7th grade, Unit 6, Lesson 13. Here is an unbalanced hanger. A. If you knew each circle weighed 6 grams, what would that tell you about the weight of each triangle? Explain your reasoning. I can tell by looking at the hanger that the left side is heavier than the right side. That means that the value for 3 triangles is greater than the value for 2 circles. We can write this as 3t is greater than 12 if each circle is worth 6. That would be 6 times 2 or 12. Divide both sides by 3. T is greater than 4. The solution is t is greater than 4. This tells me that each triangle must have a value greater than 4. B. If you know each triangle weighed 3 grams, what would that tell you about the weight of each circle? Explain your reasoning. So this time they're asking us to imagine that each triangle weighs 3 grams. That would be 3 grams times 3 triangles, or 9 grams. And since the hanger is tilting to the left, that means that 9 grams is greater than 2 circles. If we divide both sides by 2, then we have 4.5 is greater than C. That means that each circle must have a value less than 4.5. Problem number 5. From 7th grade, Unit 4, Lesson 12. At a skateboard shop, A. The price tag on a shirt says $12.58. Sales tax is 7.5% of the price. How much will you pay for the shirt? We can start by figuring out what 7.5% of $12.58. 7.5% can be written as 0.075, and of means times. So 0.075 times $12.58 equals 0.9435. That's approximately 94 cents. So let's add that 94 cents tax to the price of the shirt. $12.58 plus 94 cents equals $13.52. The total cost of the shirt would be $13.52. B. The store buys a helmet for $19 and sells it for $31.50. What percentage was the markup? First, let's figure out what the markup was. $31.50 minus $19 will tell us how much the markup is. And we can divide that by 19, the price they bought the helmet for, to find the percent of the markup. The markup was $12.50. Divide that by 19, and you get 0.657. As a percent, that would be 65.7%, which is approximately 66%. So we can say that the markup for the helmet was approximately 66%. C. The shop pays workers $14.25 per hour plus 5.5% commission. If someone works 18 hours and sells $250 worth of merchandise, what is the total amount of their paycheck for this pay period? Explain or show your reasoning. First of all, if they only sold $250 worth of merchandise and they worked 18 hours, that store is going to go out of business. $14.25 times 18 hours plus 5.5% commission on $250. We can write that as 14.25 times 18 plus 0.055 times 250. That equals $256.50 plus $13.75. Their total amount for that pay period would be $270.25. Which is actually more than the $250 worth of merchandise that they sold. So this company would go out of business real quick. Illustrative Mathematics, 7th grade, Unit 6, Lesson 17. Modeling with Inequalities. Problem number 1. 28 students travel on a field trip. They bring a van that can seat 12 students. Elena and Corinne's teacher asks parents to drive cars that seat 3 children each to transport the rest of the students. Elena wonders if she would use the inequality 12 plus 3n is greater than 28, or 12 plus 3n is greater than or equal to 28, to figure out how many cars are needed. Kieran doesn't think it matters in this case. Do you agree with Kieran? Explain your reasoning. Well, let's find out. We can solve for n for both of these equations. Subtract 12 from both sides of the inequality for both equations. Then divide both sides by 3. 3n divided by 3 is 1n, or n, and 16 divided by 3 is 5.3 repeating, which means it's more than 5 cars. Since they'd need more than 5 cars, that means that they'd need to take 6 cars. I agree with Kieran. You can use either of these inequalities to figure this out. Problem number 2. A. In the cafeteria, there is one large 10-seat table and many smaller 4-seat tables. There are enough tables to fit 200 students. Write an inequality whose solution is the possible number of 4-seat tables in the cafeteria. The information tells us that there are enough tables to fit 200 students. That means that the number of students that can sit at the tables is greater than or equal to 200.
The information also tells us that there's one large 10-seat table. That means that 10 students can be seated at that table. The information also tells us that there's many smaller 4-seat tables. That's an unknown amount of tables that seat 4 people. Our inequality would be 4x plus 10 is greater than or equal to 200. B. 5 barrels catch rainwater in the schoolyard. 4 barrels are the same size, and the 5th barrel holds 10 liters of water. Combined, the 5 barrels can hold at least 200 liters of water. Write an inequality whose solution is the possible size of each of the 4 barrels. We have 4 barrels that hold an unknown amount of water. We have a 5th barrel that holds 10 liters of water. And the information tells us that those two amounts combined holds at least 200 liters of water. The inequality in this situation would be 4x plus 10 is greater than or equal to 200. C. How are these two problems similar? How are they different? They're similar because they're represented by the same inequality, and they're different because one is dealing with tables and the number of students that sit at those tables, and the other one is dealing with barrels and the amount of rainwater that each barrel holds. Problem number 3 from 7th grade, Unit 6, Lesson 9. Solve each equation. A. 5 times n minus 4 equals negative 60. 5 times n, or 5n, minus 5 times 4, or 5 times a negative 4. 5 times n is 5n. And 5 times a negative 4 is negative 20. So we have 5n minus 20 equals negative 60. Since we're solving for n, we need to add 20 to both sides so we can get rid of that negative 20. Negative 20 plus 20 is 0, so they cancel each other out. And negative 60 plus 20 is negative 40. So now the equation reads 5n equals negative 40. Let's divide both sides by 5. So we have 1n. 5n divided by 5 equals 1n, or n, and negative 40 divided by 5 equals negative 8. So 1n, or n, equals negative 8. B. Negative 3t plus negative 8 equals 25. I can reread this as negative 3t and negative 8 equals 25. We're solving for t, and we need to get rid of that negative 8. The opposite of a negative 8 is a positive 8. So negative 8 plus 8 equals 0. They cancel each other out, and whatever you do on one side of the equal sign, you do on the other side of the equal sign. 25 plus 8 equals 33. So now the equation reads negative 3t equals 33. Since we're solving for t and we need to know the value for 1t, we need to divide negative 3t by negative 3, because negative 3 divided by negative 3 equals positive 1. Negative 3t divided by negative 3 would equal positive 1t, or 1t. Whatever we do to one side, we do to the other. 33 divided by negative 3 equals negative 11. So 1t, or t, equals negative 11. C. 7p minus 8 equals negative 22. We're solving for p, so we have to get rid of that negative 8, and we can do so by adding 8, because negative 8 plus 8 equals 0. They cancel each other out. And we have to do the same thing to the other side. Negative 22 plus 8. Now the equation reads 7p equals negative 14. Since we're solving for p, we need to divide by 7, because 7 divided by 7 equals 1, and 7p divided by 7 equals 1p. 1p equals negative 14 divided by 7. Since negative 14 divided by 7 is negative 2, we know that p equals negative 2. D. 2/5 times j plus 40 equals negative 4. So we have 2/5 times j plus 2/5 times 40 equals negative 4. We can rewrite this equation as 2/5 times j plus 2/5 times 40 equals negative 4.
2/5 times j can be written as 2/5 j, so the equation can also be written as 2/5 j plus 2/5 times 40 equals -4. 2/5 times 40 is the same as 2/5 times 40 over 1, which is 80 over 5. 80 over 5 really means 80 divided by 5, and 80 divided by 5 is 16. So now we can rewrite this equation as 2/5 j plus 16 equals -4. We're solving for j and need to get rid of the positive 16. We do that by subtracting 16 from both sides because positive 16 minus 16 is 0, canceling them out. And -4 minus 16 is -20. So the equation reads 2/5 j equals -20. We want to know the value for 1j, so we have to multiply 2/5 by its reciprocal, 5 over 2. Whatever we do to one side, we do to the other. We can multiply -20 times 5 over 2 by putting a 1 underneath the 20. It still has the value of -20, but it's written as a fraction, -20 over 1. We could multiply straight across, or we could simplify first. On the left-hand side of the equal sign, we have 1j. We didn't have any math to do. We already knew we were going to have 1j because we multiplied by the reciprocal of 2/5. But on the right-hand side, we have some math to do. 2 goes into 2 once, and 2 goes into -20 -10 times. So now we have -10 times 5 over 1 times 1. Since -10 times 5 is -50, and -50 over 1 is the same as -50, we know that j equals -50. E. 4 times w plus 1 equals -6. So we have 4 times w plus 4 times 1, and that equals -6. 4 times w is 4w, plus 4 times 1 is 4. So we have 4w plus 4 equals -6. We're solving for w, so we have to get rid of that positive 4. We can do that by subtracting 4. We need to subtract 4 from both sides. Positive 4 minus 4 is 0. They cancel each other out. And -6 minus 4 is -10. So now we have 4w equals -10. To make the term 1w, we need to divide 4w by 4. 4w divided by 4 is 1w. Whatever we do to one side, we do to the other. -10 divided by 4 is -2.5, or -2.5. So w equals -2.5. Problem number 4, from 7th grade, Unit 6, Lesson 13. Select all the inequalities that have the same graph as x is less than 4. First, let's graph x is less than 4. You can see I used a circle directly above the 4 with the line and the arrow pointing to the left. That means that the value for x is everything that's smaller than 4, but not 4. A. X is less than 2. This inequality has a different graph. It has a circle above the 2 and not the 4. B. X plus 6 is less than 10. We need to subtract 6 from both sides of the inequality sign. So now we're left with x is less than 4. So that certainly will have the same graph as x is less than 4. C. 5x is less than 20. To get the x by itself, we need to divide both sides by 5. 5x divided by 5 is 1x, or x, and 20 divided by 5 is 4. So now the equation reads 1x, or x, is less than 4. So that too will have the same graph as x is less than 4. D. X minus 2 is greater than 2. We need to add 2 to both sides of the inequality sign. -2 plus 2 is 0. That cancels each other out. And 2 plus 2 is 4. So now it reads x is greater than 4. X is greater than 4 is not going to have the same graph as x is less than 4. E. X is less than 8. This graph, there will be a circle above the 8 with the arrow pointing to the left. So E is not the same either. Problem number 5, from 7th grade, Unit 4, Lesson 12. A 200-pound person weighs 33 pounds on the moon. A. How much did the person's weight decrease? To find the difference, we can subtract. Let's use the numbers they gave us first. 200 minus 33. That's 167. 200 minus 167 is 33. The person's weight decreased 167 pounds. D. By what percentage did the person's weight decrease? The amount decreased divided by the original amount. That's 167 divided by 200. 0.835. That's approximately 84%. The person's weight decreased approximately 84%. Please subscribe to my channel if you haven't already, and you can watch the next lesson. Thanks for watching, and I'll see you next time. 7th grade, Unit 6, Lesson 18, Illustrative Mathematics. Problem number 1. For each expression, write an equivalent expression that uses only addition. A. The expression starts out as 20 minus 9. That's the same as 20 and a negative 9, or 20 plus negative 9. Next, we have plus 8, and then we have minus 7. That's the same as and a minus 7, or plus a negative 7. B. It starts out with 4x minus 7y. That's the same as 4x and minus 7y, or 4x plus negative 7y. Next is minus 5z, so we can add a negative 5z, and then finally add 6. C. Negative 3x plus a negative 8y plus a negative 4 plus a negative 8/7 z. Problem number 2. Use the distributive property to write an expression that is equivalent to each expression. If you get stuck, consider drawing boxes to help organize your work. A. 9 times 4x minus 3y minus 2/3. We have 9 times 4x plus 9 times negative 3y plus 9 times negative 2/3. 2/3 of 9 is 6, so negative 2/3 of 9 would be negative 6. 9 times 4x is 36x plus 9 times negative 3y is negative 27y plus negative 6. B. Negative 2 times negative 6 plus negative 2 times positive 3y plus negative 2 times negative 1. Well, negative 2 times a negative 6x is a positive 12x. Negative 2 times 3y is a negative 6y. And negative 2 times a negative 1 is a positive 2. C. 1/5 times 20y plus 1/5 times negative 4x plus 1/5 times negative 13. 1/5 of 20y is 4y. Negative 1/5 times negative 4x. That's negative 4/5 x. Negative 1/5 times negative 13. That's negative 13/5. D. 8 times negative x plus 8 times negative 1/2. 8 times negative 1/2 is negative 4, so the expression is negative 8x minus 4. E. Negative 8 times negative x plus negative 8 times negative 3/4 y plus negative 8 times 7/2. Negative 8 times negative x is positive 8x. Negative 8 times negative 3/4 y is positive 6y. And negative 8 times 7/2 is negative 28. Problem number 3. Kieran wrote the expression x minus 10 for this number puzzle. Pick a number, add negative 2, and multiply by 5. Lynn thinks that Kieran made a mistake. A. How can she convince Kieran he made a mistake? First, pick a number. Let's use x. Second, add negative 2. And third, multiply by 5.
B. Here's an example of a bunch of expressions that you could use for this number puzzle. The one I like the most is 5 times x minus 2. Problem number 4, from 7th grade Unit 2, Lesson 7. The output from a coal power plant is shown in the table. Similarly, the output from a solar power plant is shown in the table. Based on the tables, is the energy output in proportion to the number of days for either plant? If so, write an equation showing the relationship. If not, explain your reasoning. For the first table, I discovered that the number of days is always 500 times smaller than the energy in megawatts. The constant of proportionality is 500, which can be used to write an equation to show the relationship between number of days and energy in megawatts. And I noticed in the second table there is no predictable relationship between the number of days and the energy in megawatts. Which means for this table, you can't write an equation to show the relationship between number of days and amount of energy in megawatts. If you're not already subscribed, be sure to subscribe to my channel and watch the next lesson. Thanks for watching, and I'll see you next time.
Seventh grade, Unit 6, Lesson 19. Illustrative Mathematics, Expanding and Factoring. Problem number 1. A. Expand to write an equivalent expression. We will use the distributive property to multiply -1/4 by the two terms inside the parentheses. We can rewrite the expression as -1/4 times -8x plus -1/4 times 12y. For the first term, a negative times a negative is a positive, and 1/4 of 8x is 2x. For the second term, a negative times a positive is a negative, and 1/4 of 12y is 3y. So now the expression reads 2x plus -3y. B. Factor to write an equivalent expression. We're going to look for a common factor that we can write outside a set of parentheses. So let's look at these two terms, 36a minus 16. I think 4 is the greatest common factor, so I can put a 4 on the outside of the parentheses. 4 times 9a equals 36a, so the first term inside the parentheses will be 9a. Next, I can bring down the minus sign or the negative sign, and since 4 times 4 equals 16, this second term will be a 4. So now the expression reads 4 on the outside, 9a minus 4 on the inside. Problem number 2. Lynn missed math class on the day they worked on expanding and factoring. Karen is helping Lynn catch up. A. Lynn understands that expanding is using the distributive property, but she doesn't understand what factoring is or why it works. How can Karen explain factoring to Lynn? Since Lynn understands the distributive property, Karen can tell her that factoring is the distributive property in reverse, and that factoring takes a sum of terms and makes it into a product by writing common factors outside the parentheses. B. Lynn asks Karen how the diagrams with boxes help with factoring. What should Karen tell Lynn about the boxes? Karen can tell Lynn to think of it like this. What times the common factor equals what's in the box? C. Lynn asks Karen to help her factor this expression. Karen can use boxes to help Lynn factor the expression. Karen can start by writing the 3 different terms inside each of the 3 boxes. Next, they can find the greatest common factor of all 3 terms and put that common factor on the outside of the boxes. They could try using -4x as a common factor. -4x times y equals -4xy. Next, -4x times 3z equals -12xz.
And for the last one, negative 4x times negative 5w equals positive 20xw. Now this expression would be written like this using parentheses. Problem number 3. Complete the equation with numbers that make the expression on the right side of the equal sign equivalent to the expression on the left side. The greatest common factor is 25, so we can write 25 on the outside of the boxes. 25 times what number equals 75a? 25 times 3a equals 75a. 25 times what number equals 25b? 25 times 1b, or b, equals 25b. So the new expression would be 25 on the outside of the parentheses and 3a plus b on the inside. Problem number 4, from 7th grade, Unit 4, Lesson 3. Elena makes her favorite shade of purple paint by mixing 3 cups of blue paint, 1½ cups of red paint, and ½ cup of white paint. Elena has 2/3 of a cup of white paint. A. Assuming she has enough red paint and blue paint, how much purple paint can Elena make? The information tells us for Elena to make her favorite shade of purple paint, she needs 1½ cups of red, or 3½ cups of red, 3 cups of blue, and ½ cup of white. But it also tells us she has some extra white. She has 2/3 of a cup of white. If she made her normal batch of purple paint, she would make a total of 5 cups of purple paint. But if she were to increase the amount of paint that she uses to make the same shade of purple paint, how much paint would she make? Since 2/3 of a cup of white paint is 4/3 times larger than ½ cup of white paint, then we'll end up making 4/3 times the original amount. And since the original amount was 5 cups of paint, this new batch would be 4/3 times larger than 5 cups of paint. 4/3 times 5, or 4/3 times 5 over 1, equals 20 over 3. So this new batch would make 20/3 cups of paint. B. How much blue paint and red paint will Elena need to use with the 2/3 of a cup of white paint? 1/2 cup of white paint times 4/3 equals 2/3 cup. 3 cups of blue paint times 4/3, and 1½ cups of red paint times 4/3. That's 12/3 cups, or 4 cups of blue paint. And the red paint is 3/2 times 4/3. That's 12/6, or 2 cups of red paint. If Elena were to use the 2/3 cup of white paint, then Elena would need 4 cups of blue paint and 6 cups of red paint. Problem number 5, from 7th grade, Unit 6, Lesson 9. Solve each equation. A. Add 4 to both sides. That cancels out the negative 4 on the left side of the equal sign. And on the right side of the equal sign, we can write it as 32 over 8, or 32 divided by 8, which is equivalent to 4. Next, we need to multiply both sides by the reciprocal of negative 1/8, which is negative 8 over 1. That cancels it out on the left side, so we're left with 1d. And on the right side, we have a negative 29, so d equals negative 29. B. We need to get rid of 5 from both sides. On the left side of the equal sign, the positive 5 is canceled out. And on the right side, 16 minus 5 is 11. Next, we need to multiply both sides by the reciprocal of negative 1/4, which is negative 4 over 1. On the left side, it cancels it out, so we're left with 1m, or m. And on the right side, we have negative 44, so m equals negative 44. C. Add 45 to both sides. The negative 45 is canceled out on the left side of the equal sign, and on the right side we have positive 2. Divide both sides by 10. On the left side it becomes 1b, or b, and on the right side it becomes 1/5. So b equals 1/5. D.
First, we're going to use the distributive property and multiply -8 by both the terms in the parentheses. This becomes -8 times y plus -8 times -1.25 equals 4. In both cases, a negative times a negative equals a positive. So now it reads positive 8y plus 10 equals 4. We want to get the y by itself, so we subtract 10 from both sides. Now we're left with -8y equals -6. We want to turn that into 1y or y, so we can divide both sides by -8, because -8y divided by -8 equals positive 1y or positive y. And on the right side, we have a negative divided by a negative, which is a positive. So y equals positive 6 over 8. And 6 over 8 is equivalent to 3/4, which is equivalent to 75 hundredths. So y equals 3/4 or 75 hundredths. E. Use the distributive property to multiply 3.2 times s and 3.2 times 10. That becomes 3.2s plus 32 equals 32. Subtract 32 from both sides and you're left with 3.2s plus 0 equals 0. Divide both sides by 3.2 and you have 1s or s equals 0. So in this case, s equals 0. Problem number 6 from 7th grade Unit 6, Lesson 13. Select all the inequalities that have the same solution as -4x is less than 20. When we divide both sides by -4, we have to switch the inequality sign, and it becomes x is greater than -5. Let's take a closer look at A. -x is less than 5. Divide both sides by a -1, and then we have to switch the inequality sign, so it becomes x is greater than -5, which is equivalent to the original inequality. Let's take a look at B. 4x is greater than -20. Divide both sides by 4, and the inequality reads 4 is greater than -5, which is also equivalent to the original inequality. C. 4x is less than -20. Divide both sides by 4, and you have x is less than -5, which is not the same as the original inequality. Let's take a look at D. X is less than -5. That is also not the same as the original inequality. E. X is greater than 5. Well, that's also not the same as the original inequality. F. X is greater than -5. Yes, that one is the same as the original inequality. If you haven't already subscribed, make sure you subscribe to my channel. And while you're at it, you can watch the next lesson. Thanks for watching, and I'll see you next time. 7th grade, Unit 6, Lesson 20. Illustrative Mathematics. Combining like terms, Part 1. Problem number 1. Andre says that 10x plus 6 and 5x plus 11 are equivalent because they both equal 16 when x is 1. Do you agree with Andre? Explain your reasoning. Imagine x is 0. 10 times 0 is 0 plus 6. That's 6. Now let's look at the next one. 5 times x, and if x was 0, 5 times 0 would be 0, and 0 plus 11 is 11, and 6 is not equivalent to 11. So I would answer this like this. No, because when x is 0, they are not equivalent. Problem number 2. Select all expressions that can be subtracted from 9x to result in the expression 3x plus 5. A. A negative times a negative is a positive, and a negative times a positive is a negative. So we can rewrite this as 9x plus 5 plus a negative 6x, or and a negative 6x. We have terms with an x and terms that don't have an x, so we can combine the like terms. 9x minus 6x, that's 3x. Now we're left with two terms, 3x and a plus 5. And yes, that matches the original expression perfectly. B. A negative times a positive is a negative, and a negative times a negative is a positive. We can rewrite this expression as 9x minus 5 plus 6x. Again, we have terms with an x and terms without an x. So we can combine the like terms. 9x plus 6x equals 15x. So now the expression reads 15x minus 5. Since 15x minus 5 is not the same as 3x plus 5, then no, this expression is not equivalent to the original expression. C. A negative times a positive is a negative, and a negative times a positive is a negative. So now this expression reads 9x minus 6x minus 5. There are terms with x's and there are terms with no x's. So let's combine the like terms. 9x minus 6x is 3x. So now the expression reads 3x minus 5. And since 3x minus 5 is not the same as 3x plus 5, then no, this expression is not equivalent to the original expression. D. A negative times a positive is a negative, and a negative times a negative is a positive. So now the expression reads 9x minus 6x plus 5. Let's combine the terms that have an x. 9x minus 6x is 3x. Now the expression reads 3x plus 5. And yes, 3x plus 5 matches the original expression. E. A negative times a negative equals a positive, and a negative times a positive equals a negative. So now the expression reads 9x plus 6x minus 5. Combine the like terms. 9x plus 6x equals 15x. Now the expression reads 15x minus 5. And since 15x minus 5 is not the same as 3x plus 5, then no, this does not match the original expression. Problem number 3. Select all the statements that are true for any value of x. A. A positive times a positive is a positive, and a positive times a positive is a positive. So we can rewrite this as 7x plus 2x plus 7 equals 9x plus 7. Combine the like terms on the left side of the equal sign, and we have 7x plus 2x. 7x plus 2x is 9x. We're left with 9x plus 7 on the left side of the equal sign, and 9x plus 7 on the right side of the equal sign. So this statement would be true for any value of x. B. A positive times a positive is a positive, and a positive times a negative is a negative. So we can rewrite this as 7x plus 2x minus 1 equals 9x plus 1. Combine those like terms on the left side of the equal sign, and we have 7x plus 2x. 7x plus 2x is 9x. So on the left side of the equal sign, it reads 9x minus 1. Since 9x minus 1 is not the same as 9x plus 1, then this is false. C. A positive times a positive is a positive, and a positive times a negative is a negative. So on the left side of the equal sign, it reads 3x plus 10 minus 3x. The 3x minus 3x cancels each other out, and we're left with 10 on the left side and 10 on the right side. That means that this statement is true, because 10 equals 10. D. A negative times a positive is a negative, and a negative times a negative is a positive. So we can rewrite this statement as 5x minus 8 plus 6x on the left side of the equal sign. Let's collect the like terms. We have 5x plus 6x. That's 11x. So we can rewrite it on the left side as 11x minus 8. And the right side is negative x minus 8. Since 11x minus 8 is not equal to negative x minus 8, then this statement is false. E. A negative times a positive is a negative, and a negative times a positive is a negative. So on the left side of the equal sign, we can rewrite this as 4x minus 2x minus 8. Let's combine the like terms. We have 4x minus 2x. That equals 2x. So on the left side of the equal sign, it reads 2x minus 8. On the right side of the equal sign, it reads 2x minus 8. Since these are equal, this statement is true. F. A negative times a positive is a negative, and a negative times a negative is a positive. So we can rewrite this on the left side of the equal sign as 6x minus 2x, which is 4x. So on the left side of the equal sign it reads 4x plus 4, and on the right side of the equal sign it reads 4x plus 4. Since they're the same, then this statement is true. Problem number 4. From 7th grade, Unit 6, Lesson 13. For each situation, would you describe it with x is less than 25, x is greater than 25, x is less than or equal to 25, or x is greater than or equal to 25? A. The library is having a party for any student who read at least 25 books over the summer. Priya read X books and was invited to the party. In order to be invited to the party, she would have had to have read at least 25 books. That means that the number of books that she read was either equal to 25 or greater than 25. So we could use X is greater than or equal to 25. B. Kieran read X books over the summer but was not invited to the party. Kieran was not invited to the party. So that means that Kieran must have read less than 25 books because you had to read at least 25 books to be invited to the party. We can represent the number of books Kieran read over the summer with X is less than 25. C. C is a number line with the point above the 25 colored in, and the arrow is pointed to the left. That means X is less than or equal to 25. D. D is a number line that has the point above the 25, but it's not colored in. It's only circled, and it's pointed to the right. That means that X is greater than 25. Problem number 5. From 7th grade, Unit 2, Lesson 9. Consider the problem. A water bucket is being filled with water from a water faucet at a constant rate. When will the bucket be full? What information would you need to be able to solve the problem? You'd need to know the rate of the water flow, and you'd need to know the size of the bucket. If you're not subscribed to my channel yet, please subscribe right now, and you can watch another lesson. Thanks for watching, and I'll see you next time. 7th grade, Unit 6, Lesson 21, Illustrative Mathematics. Combining like terms, Part 2. Problem number 1. Noah says that 9x minus 2x plus 4x is equivalent to 3x because the subtraction sign tells us to subtract everything that comes after 9x. Elena says that 9x minus 2x plus 4x is equivalent to 11x because the subtraction only applies to 2x. Do you agree with either of them? Explain your reasoning. I agree with Elena because 9x minus 2x plus 4x is the same thing as 9x and a negative 2x plus 4x. 9x minus 2x is 7x, and 7x plus 4x is 11x. Since Elena is correct, I agree with Elena. Problem number 2. Identify the error in generating an expression equivalent to 4 plus 2x minus half of 10 minus 4x. Then correct the error. This says plus negative half of 10 and plus negative half of negative 4x. Negative half of 10 is negative 5 because a negative times a positive is a negative, and negative half of negative 4x is a positive 2x because a negative times a negative is a positive. We can rewrite plus negative 5 as minus 5. So the expression now reads 4 plus 2x minus 5 plus 2x. They rewrote the expression as a negative 1. Their error was that they subtracted 5 plus 2x from 4 plus 2x. That's a mistake because the 5 plus 2x are not in parentheses. So this is just a minus 5. So 4 minus 5 is negative 1, and 2x plus 2x is 4x. So this is negative 1 and positive 4x, which we can rewrite as 4x minus 1. Problem number 3. Select all expressions that are equivalent to 5x minus 15 minus 20x plus 10. A. A negative times a positive is a negative, and a negative times a positive is a negative. So we can rewrite this as 5x minus 15 minus 20x plus 10, which is equivalent to the original expression. B. 5x plus a negative 15 is the same thing as 5x and a negative 15, or 5x minus 15. Plus a negative 20x. That's the same thing as and take away 20x, or and minus 20x. Bring down the plus 10, and now the expression reads 5x minus 15 minus 20x plus 10, which is equivalent to the original expression. C. 5 times x and 5 times a negative 3, or 5 times x minus 5 times 3. We can rewrite this as 5x minus 15, and we have 5 times a negative 4x, that's a negative 20x, and 5 times positive 2, that's a positive 10. This expression is also equivalent to the original expression. D. Negative 5 times a negative x, that's a positive 5x. Negative 5 times a positive 3, that's a negative 15. Negative 5 times a positive 4x, that's a negative 20x. Negative 5 times a negative 2, that's a positive 10. This expression is also equivalent to the original expression. E. Let's combine like terms of the original expression and see what we get. 5x minus 20x, that's negative 15x. And negative 15 plus 10. That's the same as 10 minus 15, which is negative 5. This expression is equivalent to negative 15x minus 5. So this expression is equivalent to the original expression. F. Negative 5 times 3x. That's negative 15x. And negative 5 times a positive 1. That's a negative 5. So this expression is negative 15x minus 5, which is equivalent to the expression from E, which was equivalent to the original expression. Problem number 4 from 7th grade, Unit 6, Lesson 14. The school marching band has a budget of up to $750 to cover 15 new uniforms and competition fees that total $300. How much can they spend for one uniform? A. Write an inequality to represent this situation. 15 new uniforms, and let X represent the price for each uniform, plus $300 for the competition fees. This total amount has to be less than or equal to $750. This expression represents this situation. B. Solve the inequality and describe what it means in the situation. To get x by itself, we need to subtract 300 from both sides of the inequality symbol. Now we're left with 15x is less than or equal to 450. Now we need to divide both sides by 15. Now the inequality reads x is less than or equal to 30. This means that they can spend at most $30 per uniform. Problem 5 from 7th grade, Unit 6, Lesson 16. Solve the inequality that represents each story. Then interpret what the solution means in the story. A. For every $9 that Elena earns, she gives X dollars to charity. Elena wants to be sure she keeps at least $42 from this month's earnings. We'll put the 7 on the outside, which represents how many times this happened. And we have 7 times the $9 that she earned, minus 7 times X, the amount of money that she gives to charity, each of the 7 times that she earned $9. We need to subtract 63 from both sides of the inequality sign. So we're left with negative 7x is greater than or equal to negative 21. Divide both sides by negative 7 and flip the inequality sign. And x is less than or equal to 3. That means that Elena can give $3 or less for every $9 she earns.
5b. Lynn buys a candle that is 9 inches tall and burns down x inches per minute. She wants to let the candle burn for 7 minutes until it is less than 6 inches tall. The inequality they gave us is 9 minus 7x is less than 6. First we need to subtract 9 from both sides, then divide both sides by negative 7 and switch the inequality sign. The inequality now reads as x is greater than 3/7. This means that the candle needs to burn down more than 3/7 of an inch each minute. Problem number 6. From 7th grade, Unit 4, Lesson 3. A certain shade of blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. If you need a total of 16.25 gallons of this shade of blue paint, how much of each color should you mix? 1.5 plus 5 is 6.5, which is the total amount of paint for the main recipe. 6.5 goes into 16.25 exactly 2.5 times. 5 times 2.5 is 12.5, and 1.5 times 2.5 is 3.75, so you'll need 12.5 gallons of white paint and 3.75 gallons of blue paint. Subscribe to my channel and watch the next lesson. Thanks for watching, and I'll see you next time.
Seventh grade, Unit 6, Lesson 22, Combining Like Terms, Part 3. Problem number 1. Jada says, I can tell that this expression equals 0 just by looking at it. Is Jada correct? Explain how you know. First, factor x plus 5. Place x plus 5 on the outside and multiply it by negative 2/3, positive 4, and negative 10/3. We can combine these like terms. Negative 2/3 and negative 10/3 is negative 12/3. And negative 12/3 is equivalent to negative 12 divided by 3, which is negative 4. Now inside this parentheses, we're left with 4 plus negative 4, which is the same as 4 minus 4, which equals 0. Any value times 0 equals 0, so x plus 5 times 0 equals 0. So I agree with Jada. I've written out the steps for problem number 1. You can pause the video if you like. Problem number 2. In each row, decide whether the expression in column A is equivalent to the expression in column B. If they are not equivalent, show how to change one expression to make them equivalent. 3x minus 2x is 1x, or x. Now this expression is equivalent to 1x plus 0.5x. which equals 1.5x. These two expressions are equivalent. I've written out the steps for problem 2a. You can pause the video if you need to. B. 3 times x is 3x. 3 times a positive 4 is a positive 12, or plus 12. Negative 2 times x is negative 2x. And negative 2 times a positive 4 is a negative 8. 3x minus 2x is 1x, and a positive 12 minus 8 is a positive 4. So this expression is equivalent to 1x plus 4. Since 1x plus 4 is not equivalent to 1x plus 3 or x plus 3, then these two expressions are not equivalent. Here I've written out the steps for 2b. Pause the video if you need to. C. 6 times x is 6x. 6 times a positive 4 is positive 24. Negative 2 times x is negative 2x. And negative 2 times positive 5 is negative 10. 6x minus 2x is 4x. And 24 minus 10 is 14. Now let's take a look at the expression on the right. 2 times 2x is 4x. And 2 times a positive 7 is a positive 14. So these two expressions are equivalent. 4x plus 14 and 4x plus 14. I've written out the steps for problem 2c. You can pause the video if you need to. D. 3 times x plus 4, negative 2 times x plus 4, and a positive 0.5 times x plus 4. That gives us 3x plus 12 minus 2x minus 8 plus 0.5x plus 2. Collect the like terms. 3x minus 2x is 1x plus 0.5x. That's 1.5x. 12 minus 8 plus 2. That's a positive 6. So this expression reads 1.5x plus 6, which is not equivalent to 1.5. To make these two expressions equivalent, we could change 1.5 to 1.5 times x plus 4. I've written out a different example for 2D. You can pause the video if you need to. Problem number 3 from 7th grade, Unit 6, Lesson 20. For each situation, write an expression for the new balance using as few terms as possible. A. A checking account has a balance of negative $126.89. A customer makes 2 deposits. One deposit was 3.5 times as large as the other, and then withdraws $25. The starting balance is negative $126.89. The first deposit is plus X. The second deposit is 3.5 times the first deposit, which can be written as 3.5X, and a withdrawal of $25, or negative 25. Combine the like terms and you end up with 151.89 plus 4X. B. A checking account has a balance of $350. A customer makes 2 withdrawals, one $50 more than the other. Then he makes a deposit of $75. The starting balance is $350. The first withdrawal is minus X. The second withdrawal is minus X plus 50. And then finally, the deposit is plus 75. Look at the negative sign to the left of the parentheses. That means negative times a positive X. That's a negative X. So we have a total of 2 negative X's, or negative 2X. That negative sign on the outside of the parentheses multiplied by a positive 50 equals a negative 50. 350 and a negative 50 is 300. And then add the $75 at the end, and you have 300 plus 75, or 375. So we've rewritten this expression with just 2 terms, 375 minus 2x. I've written the steps for number 3. You can pause the video if you need to. Problem number 4. From 7th grade, Unit 6, Lesson 21. Tyler is using the distributive property on the expression 9 minus 4 times 5x minus 6. Here is his work. Mai thinks Tyler's answer is incorrect. She says, if expressions are equivalent, then they are equal for any value of the variable. Why don't you try to substitute the same value for x in all the equations and see where they are not equal? A. Find the step where Tyler made an error. B. Explain what he did wrong. And C. Correct Tyler's work. He's copied down the first step correctly, 9 minus 4 times 5x minus 6. He's even written down the correct second step, where we have 9 plus a negative 4 times 5x, and that negative 4 is also times the negative 6. That negative 4 times a positive 5x equals negative 20x, but that negative 4 times the negative 6 should be a positive 24 and not a negative 6. So that's where he's made his mistake. To correct Tyler's work, we can rewrite it as 9 plus a negative 20x plus 24, or 9 minus 20x plus 24. We can collect like terms. There's one term with an x in it, so we can bring that down, negative 20x. And there's 2 terms without the variable, 9 and positive 24. Well, 9 plus 24 is positive 33. So this expression is negative 20x plus 33. I've written down the steps for problem number 4, so you can pause the video if you need to. Problem number 5 from 7th grade, Unit 6, Lesson 13. A. If 11 plus x is positive, but 4 plus x is negative, what is one number that x could be? X can be any number that's greater than negative 11, but less than negative 4. B. If negative 3 plus y is positive, but negative 9 plus y is negative, what is one number that y could be? Y has to be a number that's less than 9, but greater than 3. C. If negative 5 plus z is positive, but negative 6 plus z is negative, what is one number that z could be? Z must be a number that's less than 6, but greater than 5. Pause the video so you can read the reasoning for number 5. If you haven't subscribed for my channel, please subscribe right now and watch another lesson. Thanks for watching. I'll see you next time.